At first, researchers thought their cameras were glitching. It was the only possible thing that could explain the weird view in front of them. Scalding water was blasting upward while cool methane was fizzing out right beside it. Such a combo wasn't supposed to even exist, but it did. Scientists were exploring the ocean floor near Papua New Guinea when they stumbled across a weird deep-sea hotspot. It wasn't like any other hotspot. There, super hot and cool methane-packed gas were bubbling out almost side by side. This almost never happens in nature, so the researchers were pretty shocked. They were cruising around with a deep-diving robot, the Rove Keel 6000, poking around underwater volcanoes in a remote island chain. These volcanoes hide all sorts of strange features, but nobody expected to find a full-on hydrothermal vent just tucked down there. Plus, other research trips had passed through the area before and missed it completely. This time, the robot's cameras lit up the seafloor and revealed a bizarre view: boiling vents and cold gas seeping out of the seabed. They were practically touching each other. As you understand, normally these two things show up in totally different places. Hot hydrothermal vents form when underground water gets cooked by magma and shoots upward, carrying minerals with it. Methane seeps, on the other hand, come from cold, mushy layers of sediment packed with old organic matter. This stuff slowly breaks down and leaks out as gas. But at this spot, the geology created a perfect mashup. Under the volcano sits a thick layer of organic-rich sediment. Magma creeping up from below heats these sediments, but at the same time, it also heats mineral-rich water deeper down. So you get two very different fluids, blazing hot vent water and cooler methane gas. Still, both are traveling upward through the same cracks in the seafloor. When they reach the surface, they escape just inches apart. So you end up with this bizarre little neighborhood where boiling mineral water and chilly methane bubbles are hanging out like best buddies. To ocean scientists, this is like discovering a unicorn that can also fly. It's weird, rare, and super exciting. An even more exciting thing is that right next to those weird hot and cold vents, an entire mini-world of creatures has taken over the rocks. The place is packed with huge clusters of deep-sea mussels, long tube worms, little shrimp and amphipods crawling everywhere, and even bright purple sea cucumbers sitting out in the open. The animals are so crowded together that it's hard to even see the rock underneath. Scientists are pretty sure some of these creatures are totally new to science, but they need a special trip just to identify everything living there. The strange mix of hot fluids and methane-heavy gas also changes the rocks themselves. The methane down there is super concentrated, while hot water coming from deeper inside the volcano brings chemicals with it. Together, they create unusual reactions underground. Because of this, metals like gold and silver have built up in the rocks, along with elements like arsenic, antimony, and mercury. It's like a chemical time capsule. The rocks show signs of an older, super hot phase when precious metals were forming. Today, the vents are cooler, but still active. Now, even though this deep sea area is rare and full of life, it isn't safe. Mining already happens nearby, and waste from the huge gold mine on Lahir gets dumped into the ocean. On top of that, companies have licenses to explore the seafloor for minerals and gas. All of this puts the fragile vent community in danger because many of the animals here can only survive in these exact conditions. So scientists are urging for more research and strong protection plans before this one-of-a-kind ecosystem is damaged beyond repair. This underwater treasure needs to be saved before industry wipes it out. This discovery, though, isn't the only unique ecosystem we've ever found. In January 2025, a gigantic iceberg named A84, roughly the size of Chicago, cracked off Antarctica's George VI ice shelf. This ice shelf is enormous on its own, stretching about 280 miles from end to end and about 820 feet thick. During the Antarctic summer, which is November through late February, the top of the ice shelf melts and forms long, skinny pools called ribbon lakes. They got that name because they really do look like giant icy ribbons stretched across the surface. Once A84 broke free and drifted off, it exposed part of the seafloor that had been sealed away under the ice for who knows how long. It was a place absolutely nobody had seen before. A research team aboard the ship Falkor 2 happened to be in the Bellingshausen Sea at the time. As soon as they got word about the iceberg breaking loose, they ditched their original plan. This was basically the deep-sea version of flipping over a huge rock in the woods just to see what's living underneath it. For 8 days, the scientists sent down their underwater robot, Sebastian, and explored depths of more than 4,200 feet. Down in that freezing darkness, they discovered a hidden ecosystem packed with life. Huge corals and sponges formed underwater neighborhoods that were absolutely crawling with creatures. They were not just barely alive, they were thriving. So yeah, the scientists expected to find something down there, but they definitely didn't hope to spot a full-on underwater city of ancient life. There were sea anemones that looked like tiny fluffy trees, sea spiders marching around like creatures from other planets, ice fish, octopuses, and a whole mix of other animals. The entire expedition was live-streamed to researchers around the world. By the way, the recordings are still publicly available if you're interested. Even cooler, the researchers think some of the creatures they saw might actually be brand new species. That's right, genuinely new species in Antarctica in 2025. A few might live only in this one area, and that makes sense because Antarctica is basically its own isolated planet. It's surrounded by the Antarctic Circumpolar Current, which acts like a giant watery moat that has kept the continent cut off from the rest of the world for millions of years. But even if the new species ended up being known ones, the scientists still found some extremely rare animals, like tiny snails, bristly worms, aka polychaetes, little crustaceans, and even the mysterious phantom jellyfish, which already looks like something from outer space. The scientific name for the phantom jelly is Stygiomedusa gigantea, but no one really needs that mouthful, so giant phantom jelly is fine. This thing is massive. Its bell, the umbrella-shaped top, can be more than 3 feet wide. It also has 4 long ribbon-like arms that can stretch up to 33 feet. That's the length of a school bus. Actually, the first one was collected in 1899, but scientists didn't even realize it was a completely new kind of jellyfish until 60 years later. Its body is mostly see-through with a ghostly purple tint, and instead of normal tentacles, it uses those big flowing arms to grab prey and feed itself. Even though jellyfish don't have brains, the way this giant phantom jelly moved caught scientists off guard. It seemed to steer its long arms with surprising control, especially when it drifted through tight spaces near the seafloor. It looked cautious and almost intentional, which is kinda unsettling. Another maybe kinda sorta smart creature lurking in the dark ocean? Great. The researchers also found bristleworms. Officially, they're called polychaetes, but bristleworms sounds way more fun. These worms are common in cold, deep oceans and come in tons of shapes and sizes. Their bodies are made of segments lined with tiny bristles that help them crawl, sense the environment, and defend themselves. One standout is the Antarctic scale worm, which has shiny golden bristles that make it look surprisingly fancy for a creature living in freezing darkness. So, as you see, there are still tons of places and things on Earth that don't seem real or aren't even supposed to exist. And even with our level of technology, we're unlikely to figure out all the wonders the world has to offer in the near future. The last time this volcano erupted was about 500 years ago, but recently, small tremors have grown really frequent. to such an extent that scientists have been recording more than 1,000 a month. I'm talking about the Campi Flegrei supervolcano in Italy. At one point, just a few weeks ago, the area was rattled by a 4.4 magnitude earthquake with 150 tremors in just one night. It was the strongest earthquake in over 40 years. A lot of locals spent the night in their cars, but in the morning, the shakes were followed by another earthquake, a bit weaker with a magnitude of 3.6. So, is Italy in danger? Well, the quake itself wasn't big enough to cause serious damage, but it evoked a lot of panic. At the moment, local authorities are working on grandiose emergency plans. If worse comes to worse, they'll have to evacuate hundreds of thousands of people. One of the reasons is the proximity of this area to Naples with more than 3 million inhabitants. At the moment, they're even considering an option of paying people to leave their homes. Right now, schools remain closed in the Campi Flegrei area. The authorities are allocating more than 500 million euros to ensure the safety of buildings and constructions in the area. A yellow alert is still in place in the region where 80,000 people live. There's the so-called red zone, which is the most dangerous area. There are 1,250 houses in this red zone, and all of them will be at high seismic risk if an eruption begins. Plus, more than twice as many will be at medium risk. Italy is a country prone to seismic activity, and Pozzuoli is a densely populated area that is located on one of the most dangerous supervolcanoes in Europe. Campi Flegrei has 24 hidden underground craters and dwarfs the better-known Vesuvius. Yes, the very volcano that wiped the ancient Roman city of Pompeii off the face of the earth in 79 CE. This city thrived near the base of Mount Vesuvius at the Bay of Naples. In the time of the early Roman Empire, 20,000 people lived in Pompeii. They were merchants, manufacturers, farmers, and others. The soil in the region was rich and fertile, so there were lots of orchards and vineyards. Strangely, no one knew that this black earth was the legacy of an earlier eruption of Mount Vesuvius. The area was a favorite summer destination for rich Romans. Sadly, at noon on August 24, 79 CE, all this prosperity came to an end. The peak of Mount Vesuvius exploded, sending a 10-mile-high mushroom cloud of ash and pumice into the stratosphere. For the next 12 hours, the eruption was wreaking havoc on the city. Volcanic ash and a hail of pumice stones, some of which were 3 inches in diameter, showered Pompeii. It forced the city's occupants to flee in terror. Around 2,000 people holed up in stone structures and cellars, paralyzed by fear. They hoped to wait out the eruption. Who knows? Maybe if they had decided to leave the city immediately after the beginning of the eruption, they would have had some chances to survive. A westerly wind protected the city from the first stages of the eruption. But soon, a giant cloud of hot ash and gas rushed down the western slope of Vesuvius. It engulfed the city, burning everything in its way. This disastrous cloud was followed by a flood of volcanic mud and rock, which completely buried the city. As if the volcano was making sure no one would survive, a cloud of toxic gas poured onto the city, finishing the lives of a few survivors on August 25th. A flow of rock and ash followed. It collapsed roofs and walls and turned the city into a giant cemetery. When a supervolcano erupts, the consequences are usually catastrophic. Supervolcanoes have at least once had an eruption with a volcanic explosivity index of 8, which is the largest recorded number on the index. Supervolcanoes are often extremely large, with no cone at all. That's because they're typically the remains of gigantic magma chambers that once flared up, leaving behind a caldera. They're usually located over hotspots and appear when huge volumes of magma are trying to escape from deep underground. Eventually, they burst through Earth's surface. Sometimes, all this magma gets stuck, unable to break through the planet's crust. And then, massive pools of pressurized magma gather at a depth of several miles. The pressure keeps growing because more and more magma is trying to get to the surface. At one point, a super eruption goes off. The most recent super eruption happened in New Zealand. Well, when I say recent, I meant around 26,500 years ago. That's when a supervolcano beneath the surface of Lake Taupo spewed into the air more than 300 cubic miles of ash and pumice. Imagine 500,000 Great Pyramids of Giza flying up into the air at the same time. That's how incredibly powerful that eruption was. But the most exciting and confusing thing about the eruption was that the Taupo volcano didn't simply go off like many others. At first, everything was going as usual. Tons and tons of pressurized magma had built up under the surface, and the pressure was getting higher and higher. But after the rock cracked and the first portion of lava rushed out of the crater, something went wrong, and the supervolcano took a break. Only several months later, the disastrous eruption shook the ground. Thousands of tons of lava, rocks, and ash flew high into the atmosphere. The unusual pattern of Taupo still confuses scientists. The Indonesian eruption at Toba caldera 75,000 years ago was the largest eruption in the last 2 million years. Experts estimate that the eruption could have released hundreds of thousands of tons of sulfuric acid, which might have even caused a several-degree cooling of the planet's surface. But nowadays, the impact is hard to detect because of glaciers that covered the ground afterward. There are also several so-called supervolcanoes that haven't lived up to this name yet because they've never produced any super eruptions. For example, in 1883, Indonesian volcano Krakatoa went off. The power of the eruption tore the volcano's walls open, and cold seawater rushed into its molten insides. The difference in temperatures made the volcano blow up with a deafening boom. It was clearly heard 3,000 miles away in Australia. It earned the blast the title of the loudest sound in history. But even though the consequences of this event were truly catastrophic, it still turned out not powerful enough to be called a super eruption. It only had a volcanic explosivity index of 6. Then, there's also Mauna Loa. It's a shield volcano, which means it won't produce explosive eruptions, but its sheer size makes this monster of a volcano extremely dangerous. At the moment, the volcano seems to be at peace with its surroundings. Research equipment doesn't show any signs of activity on Mauna Loa, but if Mauna Loa did suddenly erupt, lava flows could reach the ocean and the most populated and touristy places like Captain Cook very fast, in a matter of hours. The last time the volcano erupted, lava got as far as the outskirts of Hilo on the other side of the island. That's where the University of Hawaii is located. Luckily, people had a few weeks' warning to get ready for the disaster. Over its recorded history, Mauna Loa has been erupting pretty regularly, almost every 6 years. On the bright side, big island volcanoes including Mauna Loa aren't really very volatile. That's because they're shield volcanoes. These volcanoes got such a name because they aren't really very high and resemble a warrior shield placed flat on the ground. Shield volcanoes are formed by very fluid lava. It travels way farther and forms much thinner flows than the lava erupted from a stratovolcano, which is conically shaped and tall, like the infamous Krakatoa in Indonesia. So, if Mauna Loa erupts, there probably won't be ash clouds or tons of debris. The most dangerous thing will be lava. Since Mauna Loa is a shield volcano, its lava is extremely fluid and voluminous, which allows it to flow far and fast. For 70,000 years, Taftan volcano successfully convinced everyone it was extinct, but new satellite images show that its summit is rising, like something inside is stretching it, rolling it over, and cracking its neck after the world's longest nap. Scientists aren't too happy about it, so let's see if you have a reason to be worried too. Volcanoes can wake up when earthquakes shake them awake or storms mess with underground water. But scientists checked. There weren't any big earthquakes or heavy rains in southeastern Iran, where it sits. So it must be gas or magma pressure that's moving Taftan. It's like a sealed soda can heating up from the inside. Before you even hear a hiss, the pressure is building silently, waiting for a weakness. That's why Taftan's movement is such a big red flag. Pressure changes mean new internal activity. Plus, the source of pressure below its surface is at just around 1,600 to 2,070 feet deep. And that's not a lot for a volcano. When the source of pressure sits that close to daylight, it can set off small explosions from steam or gas, even if no lava ever touches the surface. This type of explosion, called phreatic, happens when water underground gets so hot so fast that it blows up like a giant pressure cooker. In Hollywood movies, volcanic eruptions always look like rivers of lava chasing people down the street. But steam-driven explosions are different, sneaky, and unpredictable. One minute everything looks calm, and the next minute rocks and superheated steam blast into the air like Earth sneezed with the power of a jet engine. For Taftan, this is exactly the scenario scientists are afraid of. You don't need flowing lava to cause destruction. A steam-driven explosion can launch boulders the size of cars and shoot ash clouds thousands of feet up. Even if you don't live anywhere near Iran, Taftan isn't just a local issue. Volcanoes breathe out gases that travel with the wind, and Taftan produces sulfur-heavy emissions when it's active. Sulfur dioxide doesn't just smell bad, but messes with air quality, irritates lungs, and reacts in the atmosphere to form particles that can dim sunlight and cool temperatures. That means neighboring countries might feel the effects even if they never see the volcano. And if a phreatic explosion blasts ash high enough, it could drift into international flight paths like volcanic confetti nobody asked for. Even smaller eruptions can have ripple effects. Remember that time a volcano in Iceland with a name I won't ever pronounce correctly blew up in 2010? It disrupted all the air travel across the Atlantic, and in our case, a modest ash plume drifting into major air corridors could ground flights across the Middle East, South Asia, and beyond. You know, gas emissions don't respect borders. They drift, mix, and settle wherever the wind decides to drop them. Alright, all this sounds pretty creepy, but with all the modern sensors, scientists should find out about an eruption in advance, right? Not really. As Taftan sits in a really remote region, setting up monitoring stations there is tricky, expensive, and frankly, was never a priority because everyone assumed the volcano was done for. So right now, satellites, not ground instruments, are doing most of the work. Satellites see the big picture, but instruments on the mountain add detail. And that's why it was so important for Taftan to be reclassified from extinct to dormant. Because dormant volcanoes need eyes on them 24/7. When a volcano is labeled extinct, countries don't invest in evacuation plans, hazard maps, or monitoring equipment. Changing Taftan's status forced everyone, from local officials to global scientists, to admit it can cause trouble. And that means preparing for ashfall, gas emissions, sudden eruptions, and the long-term questions. Questions like, what if this awakening isn't temporary? What if this is the beginning of a whole new activity cycle? Long-term, Taftan might settle down again, or it might be entering a period of renewed activity. Volcanoes don't run on human timelines. A short-term phase for a volcano could be days or years, and the uplifting summit might mean there's deeper magma movement, not just a surface burp. It has gone up by about 3.5 inches over 10 months between July 2023 and May 2024. And a mountain rising is like Earth inhaling. And if Earth inhales too deeply, it eventually exhales. And in volcanic terms, that exhale is nothing good. Right now, Taftan is breathing in, and nobody knows when it plans to breathe out. This already sounds like too much drama, but there's more where it came from. Some of the biggest, angriest supervolcanoes on Earth are starting to wake up. When one of these monsters erupts, the whole planet feels it. even people living thousands of miles away. Scientists worry because a super eruption could move faster than our ability to prepare food, evacuate cities, or deal with the chaos afterward. That's what makes supervolcanoes so scary. Not just the explosion, but how little time we might have to react. If you live near Naples, you already know at least one supervolcano and how it acts. Streets crack, steam leaks from the earth, the harbor fills with sediment, and swarms of small earthquakes rattle windows like underground thunder. All of that comes from Campi Flegrei, a massive supervolcano caldera that last erupted in 1538. For years, scientists read these signals as classic warnings of magma rising. But two recent studies, one in 2023 and another in 2025, completely changed how we understand what's really going on. And surprisingly, they brought a bit of hope with the danger. In 2023, studies zoomed in on carbon dioxide, a gas volcanoes pump out when magma starts acting up. At Campi Flegrei, CO2 levels jumped after 2005 to about 4,000 to 5,000 tons a day, which sounds like magma rising fast. But when scientists checked other gases like nitrogen and helium, the chemistry didn't fit that idea at all. It turned out that the extra CO2 came not from rising magma, but from super hot fluids underground, cooking the surrounding rocks and releasing gas on their own. In the 2025 study, lab experiments showed that the shaking comes mainly from a sealed underground water and steam reservoir. When that natural lid traps pressure, it eventually cracks and releases steam and sets off sudden quakes that people feel at the surface. That idea also explains something that always confused scientists. The earthquakes usually start close to the surface and then move deeper, which is the opposite of what rising magma would do. After the strongest shaking, the ground often sinks a little, like a balloon slowly deflating after you let some air out. None of this means Campi Flegrei is suddenly safe though. Magma still sits deep underground and steam-driven explosions can still blast out rocks, ash, and scorching gas without any lava warning you first. What's really changed is how scientists think about the danger. Just watching and waiting isn't enough anymore. If humanity only had 12 months of warning before a supervolcano eruption, we'd struggle badly. Stockpiling food, relocating people, keeping supply chains alive. It would all feel almost impossible. But don't freak out yet, because supervolcano eruptions are extremely rare. The last one happened about 26,500 years ago in New Zealand. On average, scientists think a super eruption happens roughly once every 100,000 years, but Earth doesn't follow neat schedules like a calendar. Sometimes these eruptions cluster closer together, and then the planet stays quiet for a long time. Two massive super eruptions shook the planet within the last 100,000 years. About 74,000 years ago, Indonesia's Toba volcano blew up with such force that it blasted ash across Asia, lowered the temperatures around the world, and may have pushed early humans to the brink of extinction. Then, around 26,500 years ago, New Zealand's Taupo volcano unleashed an eruption, covering huge areas in ash and reshaping the landscape we see today. There's always a chance another super eruption could arrive earlier than we expect. That uncertainty is what keeps scientists awake at night. You're in Italy, perfect sun, perfect pizza, but enjoying that view? It might be a fatal mistake. That peace is a total illusion. Literally a few miles beneath your sneakers, the Earth isn't just sleeping, it's taking a deep, nervous breath. And I mean it. Geologists are sweating right now because this hidden process isn't just happening, it's accelerating fast. When most people think about volcanoes in Italy, they think about Mount Vesuvius and that tragic story of the ancient city of Pompeii. Ash falling from the sky, a city frozen in time, a tall volcano standing over the Bay of Naples. Vesuvius looks dangerous, and it makes sense that people focus on it. But Vesuvius is not the biggest threat in the area. The real danger is harder to see. Just west of Naples is an area called Campi Flegrei. The name means burning fields. If you visit, it doesn't look like a volcano at all. There's no mountain, no cone, no rivers of lava. Instead, you see towns, ports, roads, and neighborhoods. People live their everyday lives there. That's because Campiflagre is not a normal volcano. It's a supervolcano. Forget the classic pointy mountain. Regular volcanoes build up, but supervolcanoes blow down. They leave behind a massive bowl-shaped depression called a caldera. Campiflagre is so vast you could stand right in the center and never realize you're on top of a volcano. In fact, a huge chunk of Naples is built right inside it. Can you picture this? Homes, schools, and highways sit on ground that is still active. It's like a giant chest taking a breath, rising and falling. Scientists call this brightside. Entire neighborhoods have shifted up or down by feet over the centuries. But how? That rhythm is changing fast. Around 2022, scientists started paying much closer attention to the area. Seismic activity was increasing, and new tools made it possible to look at the data in better ways. Researchers gathered records of more than 54,000 earthquakes. Most of them were small. Many were too weak for people to even feel. When all of that data was put on a map, it looked like chaos. Thousands of tiny dots spread everywhere, with no clear pattern. To the human eye, it was just noise. Too much information to make sense of. So scientists turned to machine learning. Instead of looking at each quake one by one, AI models were used to scan the entire dataset at once. The goal wasn't to predict an eruption. It was to see how stress was moving underground. That's when something new showed up. Hidden inside all that messy data was a large circular fault system, a ring-shaped crack in the Earth's crust that outlined the edge of the caldera. It had always been there, but it was buried in the noise. Once the AI pulled it out, it changed how scientists understood the whole system. This kind of ring fault matters a lot. It acts like a pathway. Pressure from deep underground, magma, hot water, and volcanic gases can move along it more easily than through solid rock. Instead of pressure spreading out evenly, it gets focused along this ring. That alone would be concerning, but the story doesn't stop there. The new study uncovered something scary under Pozzuoli. The city is sitting on a crossroads of deep cracks in the earth, including the newly discovered ring fault. Scientists used to think this area was low risk, but the new numbers tell a different story. Pozzuoli sits on the weakest spot of the whole system. Since the rock is already so broken up underground, the pressure has an easy way out. That means when the magma chamber breathes, this city takes the hardest hit. Residents aren't just neighbors to the volcano. They're sitting right on top of the exhaust pipe. Based on this new data, scientists are saying that magnitude 5 earthquakes are not just possible, they're likely. To many people, that number doesn't sound all that scary. We see headlines about magnitude 7s and 8s in the Pacific all the time. But Campiflagre plays a completely different set of rules. The danger here isn't just the size of the quake, it's the location. In places like Tokyo, quakes are usually deep, so by the time the waves reach you, they feel like a rolling motion. But here, earthquakes are incredibly shallow, sometimes starting just a few thousand feet below the pavement. That makes a huge difference, because the explosion is happening right under your feet. The ground doesn't roll, it jolts hard. It's a violent vertical kick that amplifies the damage. Even a small quake here hits with the intensity of a truck crash. And that kind of force is bad news, also because of the buildings. Many structures in this area are old, historic treasures, sure, but dangerous. They were built centuries before modern seismic safety codes were even a concept. We're talking about things that were never designed to move. Thick stone walls, aging water pipes, and rusted gas lines. None of this handles shaking very well. Modern steel bends. These old stones just crack. All of this destruction is driven by a phenomenon called brightside. Think of it as a massive hydraulic system operating deep underground. Miles below the surface, a volatile mix of magma, superheated fluids, and volcanic gases are constantly trapped. Over time, that cocktail builds up immense pressure. As the pressure grows, it pushes against the crust, literally lifting the ground. and the entire city upward. When the gas escapes or the pressure drops, the ground sinks back down. It's a slow, relentless cycle of rising and falling. And this isn't just a scientific theory. We have clear physical proof. In Pozzuoli, there's an ancient Roman building called the Temple of Serapis. Its stone columns are marked with holes made by sea creatures that only live underwater. Those holes show that the building once sank below sea level and stayed there for a long time. Later, it rose back up again. The ground didn't move suddenly, it moved slowly, over centuries. The earth here has always been unstable, slowly breathing in and out. What scares scientists today is how fast the movement is happening now. Since April 2025, the ground has pushed up 0.6 inches every single month. That doesn't sound like much, but in geology, that's fast. Over a year, it adds up to nearly 7 inches. Buildings are not designed to move like that. As the ground lifts, foundations get stressed, pipes stretch, roads bend. At the same time, the ring fault is being pulled tighter and tighter. Systems under stress don't always fail slowly. Sometimes they break all at once. It wouldn't take a huge event to push things over the edge. A small shift in magma, a sudden release of gas. Something like that could trigger stronger earthquakes. If that scenario plays out, we're not talking about some cracked plaster or a few broken windows. It hits the panic button for the entire red zone. And let's be real, evacuating Naples isn't just hard. It's a logistical nightmare straight out of a disaster movie. We're talking about a critical red zone holding 500,000 people, from Pozzuoli to western Naples, who would have to evacuate the second the alarm sounded. And right next door is the yellow zone, where another 800,000 residents are sitting directly in the path of choking volcanic ash. These are narrow, winding, ancient streets built for donkeys and carts, not for 500,000 panic-stricken people trying to leave at the same time. It's a recipe for absolute gridlock. We're talking bumper-to-bumper traffic where nobody moves an inch. Then there's the money. The economic hit would be staggering. Overnight, one of the most vibrant places on Earth turns into a ghost town. No tourism, shops boarded up, businesses wiped out. The ripple effect wouldn't stop at the Italian border. It would hit the whole European economy. Now, sure, this isn't ancient Pompeii. We have satellites and smartphones. We aren't totally blind. So hey, apparently, there's absolutely no need to be worried, right? New Zealand's most active and dangerous volcano is erupting again, reminding everyone of its power. This time, ash from the White Island volcano has drifted across flight paths, sparking concern and forcing airports to cancel flights. Locals know all too well that this volcano should never be underestimated. The current eruption comes just a few years after a catastrophic explosion claimed the lives of tourists and guides who were on the island. But against all odds, some people managed to survive what could have been their tragic end. It was December 9th, 2019. The sky was clear and blue over the Bay of Plenty, a big bay on the northern coast of New Zealand's North Island. It felt like the perfect day for sightseeing. The main attraction in the area is the White Island volcano, also known as Whakaari. It is huge, with its peak rising about 1,000 feet above sea level. Its impressive size and stunning views have been drawing visitors from all over the world for years. Actually, we're talking about very brave visitors, as being near an active volcano comes with serious dangers, such as explosive eruptions, fatal emissions of sulfur dioxide, superheated steam, earthquakes, rockfalls, and even tsunamis. Experts normally say that these catastrophic events are extremely rare, which is true, but rare doesn't mean impossible. On that doomed day, 47 people were having the best time exploring the island. Little did they know that everything was about to change at exactly 2:11 that afternoon when the volcano erupted. A fisherman who was out at sea near the volcano described it as a huge explosion going off. forming a mushroom cloud as it expanded. Photos taken from a distance and satellite images show that a thick white cloud filled the sky a couple of moments after the eruption. Authorities then issued an alert about a moderate volcanic eruption, warning people living near the volcano to stay inside and close their windows and doors to prevent ash from coming in. But the authorities' nightmare truly began when they checked cameras on the island and saw what appeared to be people going inside the crater just 1 minute before the eruption. Right at that moment, they knew they had to launch an urgent rescue operation. Time was running out, and every second counted. The people were in serious danger. 7 rescue helicopters were sent to the scene with paramedics on board. They managed to find the first survivors, and 7 of them were seriously hurt. At around 5 in the morning the next day, officials announced that 23 people had been rescued from the island. They knew more people were still trapped there, but rescue teams could not communicate with any of them. And there was something even more worrying in the back of their minds: the risk and fear that a second eruption might happen at any moment. Recovery efforts during that week were really challenging due to ongoing seismic and volcanic activity. Heavy rain, low visibility, and toxic gases made things even tougher for the teams on the ground. Unfortunately, 22 people lost their lives in this tragedy, either due to the explosion or from their injuries. Those who survived tell heroic stories about that day. One of the survivors was from Sydney and was only 19 years old when he went on a family trip to New Zealand. The itinerary included a visit to the famous White Island volcano. He said that his tour group, including his family members, was caught in a relatively flat and open area on their walk down from the crater when the volcano erupted. Then he was thrown over a mound by the force of the eruption before curling up in the fetal position, covering his head with his hands. He felt like he was being hammered by a sandstorm, like in movies where characters can't see a few feet in front of them. Once the eruption clouds lifted, the island returned to the clear day it had been before, except everything was covered in gray ash. That was when he saw his father struggling to breathe. He remembers spending about 20 minutes thinking about what he could do, even though he was feeling unbearable pain. With hope of survival, he gathered all his strength to get up and seek help. Eventually, he managed to reach the pier where he was rescued and taken to a hospital. He spent 8 days in intensive care and, like a hero, managed to survive. Unfortunately, he never saw his family again. Along with other survivors, this young man was one of those who sought justice after the incident. According to him, he wasn't given any indication of dangers before going on the trip, and only had a short safety briefing that day with no emergency plans in place. This brings us to an important question regarding this tragedy. How could no one have predicted what was going to happen? Were they all really caught by surprise? To answer these questions, we need to understand a bit about the nature of volcanoes and how they behave. So, New Zealand is situated on 2 tectonic plates. These plates are always moving very slowly, and what happens there, specifically, is that the Pacific Plate slides under the Indo-Australian Plate. The problem is that when this subduction or sliding process happens, it can create deep trenches. As the edge of the denser plate moves down, the pressure and temperature around it go up. This causes changes in the plate that melt the rock above it, and that melted rock can rise and come through a volcano. This geological process has helped shape the beauty of New Zealand with its rugged terrain and stunning mountain landscape, but it can also be destructive. There are several active volcanoes in the country, and White Island is just one of them. Eruptions like the one that happened in 2019 have been occurring for tens of millions of years. White Island volcano is a stratovolcano, which means it has that classic cone shape like Stromboli in the Mediterranean or Mount St. Helens in Washington. It's also part of the Ring of Fire, a region filled with volcanoes that surrounds the Pacific Ocean. What makes this area so dangerous is the molten rock or magma hiding underneath these volcanoes. This magma is usually thick and filled with gas, which can lead to powerful and explosive eruptions. According to specialists, the eruption on White Island was likely a steam eruption. Stratovolcanoes often have many cracks that let water in. When this water meets hot magma, it turns into superheated steam that usually escapes through vents. If these vents get blocked, pressure builds up, which can lead to an explosive eruption that blasts steam, hot ash, and rock into the air. The thing with steam eruptions is that they're considered relatively small eruptions, but still fatal if you get too close. And it's precisely because they're small that they become very hard to predict. They can strike without warning, catching everyone off guard and turning a seemingly calm day into a life-threatening situation in an instant. So, about that day in 2019. Yep, the volcano really surprised the tourists and their guides, but we need to clarify one thing. About a month earlier, experts did notice an increase in toxic sulfur dioxide coming from the volcano. They raised the danger alert to level 2, which stands for moderate to heightened volcanic unrest. But what happened was that, back then, it was still pretty common for tour operators to keep running their tours, even with a level 2 alert. Unfortunately, the country learned the hard way that volcano tourism can be really dangerous, and White Island has been off limits since then. I mean, you can't get too close anymore, going there by boat or helicopter. But for those with a taste for adventure, scenic flights are still an option, allowing you to catch a glimpse of the volcano from a safe distance. Frankenstein, unreasonably cold weather, and tons of lava. What do these things have in common? They all trace their origins back to Mount Tambora. This volcano in Indonesia had such a massive impact that the aftermath could be felt in Switzerland even a year later. And these spots are thousands of miles apart. Soon, we might be facing something similar again. Stick around, because I'm about to reveal the exact spot where the next eruption is expected to happen in 2025. Back in 1815, Mount Tambora erupted with unprecedented force, sending a colossal cloud of fine particles into the atmosphere. This cloud reflected sunlight, leading to global cooling and even the year without a summer in 1816. Temperatures plummeted, crops failed, and families worldwide faced food shortages, compounded by various health issues. Fun fact: Frankenstein appeared because of abnormally cold weather in the summer of 1816. The author got stuck indoors in Switzerland and wrote this story to pass the time. But that is the only positive aftermath. In England and Ireland, people struggled to find food. The crops were too bad that year, and this year without summer cost them lives, all because of the eruption in Indonesia. While many other volcanoes have erupted since then, none have had consequences as dramatic as Tambora. However, climate professor Marcus Stoffel from the University of Geneva believes potential serious eruptions aren't just a matter of luck, it's only a matter of time. So it's up to us. We can sit back and wait for the inevitable, or we can start preparing today. This future eruption will happen in a world that's vastly different from the one in 1815. Not only is our planet more densely populated now, but we've also experienced irreversible changes that affect our daily lives. Now, if you think volcanoes are always the bad guys, think again. They've actually played a crucial role in shaping our planet. They help with land formation, atmospheric development, and climate modulation. Just look at Yellowstone, for example. When thick lava oozed to the surface, it spread across the landscape and transformed the area forever. When volcanoes blow their tops, they release a mix of lava, ash, and gases, including carbon dioxide. But don't worry, compared to the emissions from fossil fuels, the amount from volcanoes is pretty tiny. What scientists are really keeping an eye on is sulfur dioxide, because it can have a big impact on our climate. When a major volcanic eruption happens, it can send sulfur dioxide soaring into the stratosphere, which is about 7 miles up in the atmosphere. Once there, it transforms into tiny aerosol particles that scatter sunlight, helping to cool the planet. This cooling effect isn't immediate though. Those particles can hang around for a couple of years and even circulate all around the globe. Nowadays, we've got special equipment to monitor sulfur dioxide emissions from space. Take Mount Pinatubo in the Philippines. During its eruption in 1991, it released around 15 million tons of sulfur dioxide. Now, while that's a lot, it wasn't quite as massive as the eruption of Tambora. Still, Pinatubo managed to lower global temperatures by about 0.5 degrees Celsius for several years. Tambora, on the other hand, dropped average global temperatures by about 1 degree Fahrenheit. I know what you might be thinking. That's not much, but trust me, it makes a difference. If the planet warms up by just 1 degree Fahrenheit, it could really mess with sea levels. Experts think we might see a rise of up to 8 inches by the end of this century. This could wipe out a lot of farmland and coastal habitats, which would be a huge blow to many communities. So maybe a volcano eruption that can cool off the planet is like a natural mechanism helping us out? Not exactly. While it does cool the planet off, don't get tricked into thinking it's the kind of coolness our planet needs. Such temperature shifts can severely mess up with the crops, like they did in 1816. There's also evidence that major eruptions can disrupt rainfall patterns, leading to drier conditions in monsoon regions across Africa and Asia. You see, the summer monsoon relies on the temperature difference between land and ocean, which can be altered by volcanic activity. Interestingly, a warmer climate may enhance the cooling effects of volcanic eruptions. Experts explain that the formation and movement of aerosol particles depend on climate conditions. As global temperatures rise, faster air circulation can lead to smaller aerosol particles, which are more effective at scattering sunlight and thereby intensifying the cooling effect. Oceans also contribute to this dynamic. A warming ocean surface creates a stratified layer, hindering the mixing of warm and cold water, which could mean that volcanic eruptions primarily cool the upper ocean layer and the atmosphere above it, according to Stoffel. Moreover, climate change may influence volcanic systems directly. The melting of ice can trigger more eruptions by reducing the pressure that allows magma to ascend more easily. Additionally, increased rainfall associated with climate change can seep into the ground and interact with magma, potentially sparking eruptions. While the prospect of a cooling period due to a volcanic eruption might seem beneficial amid climate change, scientists warn that the effects could be dire. The immediate consequences could be severe, particularly for the estimated 800 million individuals residing near active volcanoes. A major eruption could devastate entire cities. For example, Campi Flegrei, located near Naples, Italy, is showing signs of increased activity and threatens the lives of about 1 million people. Now, if you're from Oregon, beware, as experts say this state might experience volcano eruptions. Are you scared? Don't be. It's actually not as scary as it seems. Let me explain why. There are more than 80 volcanoes in Oregon, but we're not interested in a single one of them because it's an underwater volcano that is likely to erupt in 2025. Axial Seamount is the most active volcano in the Pacific Northwest, yet it remains largely unknown to the public due to its location approximately 300 miles offshore and nearly a mile beneath the ocean's surface. While its upcoming eruption is expected to pose no threat of a tsunami or significant land-based earthquakes because of its depth and distance from the Cascadia Fault, the data gathered from studying its eruptions can enhance our monitoring of potentially more hazardous volcanoes. Let's call it a friendly eruption, shall we? In reality, predicting eruptions is a complex endeavor. We often encounter alarming headlines such as, "Yellowstone is about to erupt." Should we take these claims seriously? Not really. Yes, Yellowstone sits atop an active supervolcano that has experienced 3 major explosive eruptions in the past 2.1 million years. The last eruption occurred approximately 70,000 years ago, with the most significant explosion taking place around 631,000 years ago, forming the massive Yellowstone caldera. Naturally, many people are curious about whether Yellowstone will erupt again and when that might happen. Fortunately, scientists are employing new techniques to delve into these questions. A recent study suggests that Yellowstone is unlikely to experience another major eruption anytime soon. The reason is that the magma beneath the park is divided into a network of separate chambers. While there is a substantial amount of magma present, it's not sufficiently interconnected to support an eruption. Previous studies proposed that the existence of a massive layer of magma beneath Yellowstone, but these latest findings change that notion. To gain a clearer understanding of the subterranean dynamics, researchers utilized a technique called magnetotellurics, which employs Earth's natural electromagnetic fields rather than seismic waves. Since magma is a good conductor of electricity, this method is particularly effective for mapping molten rock and comprehending underground activity in volcanically active regions. By using magnetotellurics, scientists created a detailed map of the magma under Yellowstone, enabling them to make more informed predictions about future eruptions. But what will happen if an eruption similar to Mount Tambora occurs? By and large, there will be huge climate chaos. Yeah, the best scientists are looking for the solution should it really happen, but they don't have it yet. So technically, we're not ready for the second Mount Tambora. But for now, we're pretty much safe. No major eruptions are predicted. Whew!
Oh boy, scientists predict a volcanic eruption that is likely to be one of the most destructive in the history of our species. There's a 1 in 6 chance of it happening in this century, and it could seriously change the climate even more and put millions of lives in danger. Back in January 2022, the Hunga Tonga Hunga Ha'apai volcano erupted in the South Pacific Ocean, creating a huge explosion. It sent tsunamis all the way to Japan, North America, and South America. Tonga itself was hit hard, with damage costing nearly 20% of the country's entire economy. Now, researchers at the Niels Bohr Institute in Copenhagen have studied ice samples from Greenland and Antarctica, and their findings are worrying, predicting potential global volcanic disaster. They say there's a real chance of a much bigger eruption, a whopping 10 to 100 times larger than Tonga's. In the past, eruptions this size used to change the climate and even cause civilizations to collapse. Despite future volcanic eruption risks, experts say the world isn't prepared at all. Michael Cassidy, a volcanologist from the University of Birmingham, warns that no sufficient effort is made to handle a disaster like this. He says that NASA and other space agencies spend billions on asteroid defense. At the same time, a volcanic supereruption is way more likely than an asteroid impact. And right now, there's no global plan for dealing with a massive eruption, even though it's likely to be far more destructive. The last magnitude 7 eruption happened in 1815 at Mount Tambora in Indonesia. Then, thousands of people lost their lives in just a few days. The disaster also disrupted weather and caused food shortages worldwide, affecting millions. That eruption was the biggest in recorded history. It blasted a massive cloud of particles into the sky. Those particles blocked sunlight, cooled the planet, and caused worldwide chaos. The year after the eruption became known as the Year Without a Summer. Temperatures plummeted, crops failed, famine spread, and a cholera pandemic broke out, leading to tens of thousands of lost lives. A shocking fact, the eruption may have even inspired Mary Shelley to write Frankenstein while stuck indoors during the unusually cold summer of 1816 in Switzerland. Now, since then, many volcanoes have erupted, but none have matched Tambora's scale. Now, over 200 years later, scientists warn that there's a new supervolcano threat. Another massive eruption could be on the way, and the world might not be ready for it. So, while scientists seriously discuss the likelihood of the next volcanic eruption, experts are calling for urgent action to prepare before it's too late. So, the thing is, A massive volcanic eruption today could be even more devastating than the year without a summer. Unlike back then, we're already dealing with all kinds of weather changes and a more fragile global system, which could make the effects even worse. Dr. Michael Rampino, a geological scientist, warns that the world is more unstable now, and it means that a modern-day mega-eruption could have even more severe consequences. But this time, greenhouse gases from fossil fuels may make the aftermath of such an eruption even colder instead of warmer. So we're talking about volcanic activity endangering humanity. Dr. Thomas Aubrey, a volcanologist, found that in a hotter, more turbulent atmosphere, the sulfur dioxide gas released by a volcanic eruption would spread faster and farther than in the past. This gas forms sulfate aerosols, which reflect sunlight and cause global cooling. Because these tiny particles would be more evenly distributed, they'd have a stronger cooling effect than in 1815. Another atmospheric scientist at Cambridge explains that the size of these airborne particles matters. It affects how they absorb sunlight, and in a future warmer climate, an eruption could make the surface cooling stronger by 15%. At the same time, there are still many unknowns. Scientists from the University of Geneva say that we're only beginning to understand the full impacts of such an event. It's also difficult to precisely estimate future volcanic eruption risks, since we have very little data on older eruptions. So, to understand past volcanic activity, researchers analyze ice cores from Greenland and Antarctica, as well as ancient tree rings. Those act as historical records of weather changes. These measurements suggest that several eruptions in the past few thousand years temporarily cooled the planet by about 2 to 2.5 degrees Fahrenheit. One of the most catastrophic examples is the 1257 Somalus eruption in Indonesia, which was so powerful that it likely triggered the Little Ice Age. It was a period of global cooling that lasted for hundreds of years. More recently, the 1991 Mount Pinatubo eruption in the Philippines slightly cooled Earth for a few years. Because this eruption happened in the satellite era, scientists were able to measure exactly how much sulfur dioxide was released and how it affected the atmosphere. But even with modern tools like satellites and seismic instruments, scientists still have difficult times forecasting the next big volcanic eruption. Luckily, even though we can't predict the exact timing, we can study worst-case scenarios to help authorities prepare. This includes creating evacuation plans and stockpiling food in case of global crop failures caused by volcanic cooling. The changes in weather patterns might make volcanoes more active. Melting glaciers can reduce pressure on underground magma, which will increase the chances of an eruption. Plus, more extreme rainfall, which is becoming more and more common, can seep into volcanic cracks and cause powerful steam-driven explosions. It can affect both active and dormant volcanoes. Because of these risks, researchers are now mapping volcanoes that are the most vulnerable to climate change. Their studies show that the highest supervolcano threat comes from such areas as Iceland, Chile, and Indonesia. Those are places where glaciers are melting quickly or rainfall is increasing dramatically. A 2022 study found that 716 volcanoes worldwide, that's about 58% of all known active above-ground volcanoes, could be triggered by extreme rainfall, increasing the likelihood of another mini ice age. Now let's get back to that Hunga Tonga Hunga Ha'apai eruption that occurred on January 15, 2022. Scientists have confirmed that it created the highest plume ever recorded. The volcano, located underwater in the South Pacific, sent an ash cloud 187,000 feet high. That's higher than any previously recorded eruption. What makes this eruption even more remarkable is that it was the first to ever reach the mesosphere. It's the third layer of Earth's atmosphere. The mesosphere begins at about 160,000 feet above Earth, where meteors start burning up and creating shooting stars. To measure the plume's height, researchers from the University of Oxford and RAL Space used data from 3 geostationary weather satellites. Before this, the record for the highest volcanic plume was held by Mount Pinatubo's 1991 eruption in the Philippines, which reached 131,000 feet high. Interestingly, this kind of measurement was only possible thanks to modern satellite technology, and a decade ago, no one would have been able to do this. Another volcano we should mention in relation to a potential global volcanic disaster is located on Iceland's Reykjanes Peninsula. Its latest eruption happened in November of 2024, leading to evacuations in nearby areas. The eruption began just after 11 p.m. with little warning. The volcano released orange lava from a nearly 2-mile-long fissure. Authorities ordered evacuations for about 50 homes and guests staying at the Blue Lagoon Spa Resort, a popular tourist destination southwest of Reykjavik. While air travel was not affected, officials still warned of potentially dangerous gas emissions spreading across parts of the peninsula, including the nearby town of Grindavik. Grindavik, home to 3,800 residents, has repeatedly witnessed volcanic activity, and past eruptions even damaged its infrastructure and forced evacuations. For example, in August 2024, a 2.5-mile-long crack opened at the Sundhnúkangigar crater near Grindavik. It led authorities declaring a state of emergency as lava flowed in multiple directions. Fortunately, Iceland's meteorological office reported that the latest eruption was significantly smaller than the one in August. Geophysics experts conducted aerial surveys and figured out that the situation appeared less intense than the previous eruptions. These days, Grindavik is not at risk, but the possibility of further developments cannot be ruled out. Scientists predict more volcanic eruptions.
Ever since Plato wrote about the allegory of Atlantis, humanity has been fascinated with the possibility of the discovery of a thriving underwater civilization. Fancy joining me on a trip to a few historic underwater sites? Let's see what we can find out about ancient civilizations. The first one on our list is what is being called the underwater Stonehenge. Scientists have recently discovered a mysterious pile of cairns that stretch for miles under the shimmering waters of Lake Constance at the borders of Switzerland, Germany, and Austria. Archaeologists began to explore the site back in 2015, and they haven't been able to understand yet what it was actually used for. What they do know is that there is a 12-mile line of 170 human-made stone cairns under Lake Constance. Scientists say this was most likely the result of a combined work of several villages. The cairn site was probably used for some collective purpose. The formations are huge. Some of them are several dozen feet wide. The most amazing discovery so far is that the site dates back to around 5,500 years ago. Now, what were we humans doing back then? We were living in the prime years of the so-called Stone Age. We were beginning to make artifacts from stone and use them to hunt and eat. Can you imagine what a knife and fork might have looked like back in those days? It's no coincidence that scientists call this site the underwater Stonehenge, though. Both sites are believed to have been built around the same period of time. You see, Stonehenge dates back to around 3,100 BCE. Both sites carry the distinct characteristic of stone monuments built in a circle. Not to mention the fact that scientists also haven't figured out why on earth our early ancestors would feel the need to build a monument such as Stonehenge. Well, the mystery of Lake Constance hasn't been solved yet. Who were the Neolithic people from this area? And for what purpose did they go through such an amount of work and effort to build this huge stone site? Next, we're taking you on a tour of the Ryukyu Islands just off the coast of Japan. You're diving deep down to an archaeological site. But I should warn you, the waters of the Pacific Ocean are far from smooth. It doesn't take long before you see a huge structure, thanks to the sunlight shining down on the seabed. At first, it looks like Machu Picchu's ruins located across the globe in Peru. As you approach the site, you slowly figure out its forms. A pyramid-shaped structure, arches, staircases. It's something that could have easily been a palace or a castle. Could this be a sign of human activity? What you've just seen is known today as the Yonaguni Monument. It also goes by the name of Japan's Atlantis. The entire monument is about the size of 5 soccer fields and the height of a 5-story building. Its most surprising feature is its expanse of terraces. Explorers and scientists believe that Yonaguni might be 10,000 years old. But whether it's a human-made structure or a natural formation is still under debate. For Japan's top marine geologist, Professor Masaki Kimura, Yonaguni is the heritage of a lost civilization. Kimura has dived to the bottom of the ocean to explore the ruins over 100 times over the past 10 years. According to him, there are clear signs of human activity down there. On the monument's surface, there is a triangle-shaped concave that is a historical symbol of water fountains in the region. There's also a giant turtle carved on the eastern side of the structure. And, according to Kimura, turtles have an important cultural meaning. Several pieces of stone tools have been recovered from the site. Their estimated age is around 10,000 years. However, not all scientists support this theory. For many, Yonaguni is the result of thousands of years of erosion. The fact that the monument is composed of one massive rock leads them to believe it's not human-made. The defined edges and flat surfaces resemble a natural formation in Northern Ireland, known as the Giant's Causeway. The basalt columns look like the ruins of a palace, but they're actually the result of volcanic activity in the region. Now, you're flying to the coast of Greece, 4 hours away from Athens. More specifically, you're in the Peloponnese Peninsula. You dust off an old snorkel and head for a free dive on a bright sunny day. Sometime into the dive, you start noticing patterns on a seabed. 13 feet below the surface, outlines of familiar objects start to appear, one by one. As you continue swimming, what looks like the outline of an entire city emerges in front of your eyes. Are you wondering how water could have taken the whole city? Rocks are perfectly aligned into what appears to be the foundation of a building. This is Pavlopetri, an ancient city you've probably heard about for the first time. It was discovered by Nicholas Fleming, a British oceanographer, when he was on vacation in Greece. He had heard rumors about Pavlopetri's existence and indeed found several artifacts on the seafloor. He went back to the area a year later with the team. They found a site filled with pots, storage vessels, and tools. A kernstone, for instance, is a tool used for grinding grains and turning them into flour. Multiple amphoras indicate that this settlement dates back to the Bronze Age, 5,500 years ago, when people started living in towns. The settlement is believed to have existed for over 2,400 years. Today, Pavlopetri is considered the oldest submerged town ever discovered, and what's impressive is that it wasn't a simple village. It was a vibrant port city with stone buildings, a marketplace, streets, and even squares. The next stop on our voyage is one of today's most famous underwater cities that has been turned into an archaeological park. The city of Port Royal in Jamaica exists only below the surface, but in 1692 it was one of the wealthiest cities in the Western Hemisphere. Port Royal was the center of the British Empire at the time and an important trade city that attracted people from all over the region. It was also home to real-life pirates of the Caribbean. On the morning of June 7, 1692, the people of Port Royal met a different fate than they had probably expected. The city woke up shaking. People were thrown out of their beds by the power of a massive earthquake, ranking 7.5 on a Richter scale. One survivor said he had seen Earth opening up and swallowing the whole town. What he said could be true, as the city was mainly built on sand. The ground swallowed buildings, roads, you name it. Geysers erupted, and finally, waves as big as 10-story buildings hit the city. About 33 acres of the city disappeared under the water. Amazingly, most of its 17th century remains are still in good condition under 40 feet of water. Archaeologists have found taverns, storage rooms, kitchens, and recreational buildings used for diverse purposes. You can also see a grand lion statue, a submerged bridge, and many picturesque arches. Of course, I saved the best for last: India. Just off its coast lies another sunken marvel. A site known as the Lost City of Cambay is located in the Gulf with a similar name. It remained undiscovered until 2001, when the National Institute of Ocean Technology made a routine water assessment. With the help of sonar technology, which sends a wave sound to the bottom of the sea, they found something far beneath the surface. Images showed well-defined geometric shapes spread along a 5-mile stretch. The remains date to more than 9,500 years ago, meaning this civilization was lost at around the end of the Ice Age. Debris recovered from the site included construction material, pottery, beads, sculptures, and even bones. Scientists argue whether these artifacts are indeed from the site, but if they truly are, then the lost city of Cambay might be the oldest civilization in the world.
The floor is lava. Haha, just kidding. But honestly, it's kind of falling apart. You might not feel it yet, but a huge part of North America has already lost 37 miles worth of rock from its foundation. And no, this isn't about earthquakes or giant sinkholes. It's about the continent losing pieces of the very thing that keeps the ground from wobbling around like a bad carnival ride. A team of researchers has just dropped a geological bombshell. Part of North America's ground is thinning out like a very sad, very slow ice cream drip. How do they know? They basically gave Earth a high-tech full-body MRI and created 3D maps showing how rocks once considered indestructible are now melting away into the planet's guts, like an upside-down cheese pizza inside an oven. But to really understand this mess, you first have to meet my old friends, cratons. Cratons are like the roots of the continents. They're thick, tough, and ancient. We're talking billions of years old. These bad boys survived meteor impacts, supervolcanoes, and even the tectonic movement of plates. If the plates got into fistfights, for example, you can bet we would see mountain ranges being born. If they got a divorce, drifting apart from each other, then a whole new ocean would be born. All of these things leave scars on the surface of Earth, but the cratons seem to always remain unfazed, like the cockroaches of geology. And since a craton can basically get punched in the face and feel nothing, scientists always assumed these things were nearly indestructible. But then, a group of researchers took their fancy machines to the test and realized that, wait, the cratons are falling apart? How? Enter the Farallon Plate, a really ancient tectonic plate that started to slide under North America's major plate over 100 million years ago. This is a pretty normal process, actually. It's called subduction, and it's how Earth recycles rocks and keeps itself from overheating. This subduction thing has been happening for so long that, by now, the Farallon is almost 400 miles away from the craton, sitting pretty chill at the lower mantle, weirdly close to the outer core of our planet. But the Farallon has been causing trouble, like that one roommate who moved out but keeps leaving weird stuff in the fridge. You see, as it sinks, it tugs on the bottom of North America's foundation, stretching it out and causing pieces to fall off into the deep mantle. And if that wasn't enough drama, the sinking Farallon has also leaked water and carbon dioxide into the surrounding rocks, making the craton even softer and easier to shred apart. Thanks, Farallon. Very cool of you. By studying hundreds of earthquakes across thousands of monitoring stations, scientists have confirmed the story. Big chunks of continental material are dripping downward, thinning the craton by as much as 37 miles. That's more missing rocks than can fit into a milk carton. Sounds dramatic, right? But don't worry. This is happening at a snail's pace. It'll take millions of years for anything noticeable to happen. Your great-great-great-great few grandkids from the distant future might still be standing on solid ground. But don't get too comfy. This thing may not be an urgent problem, but there's another type of sinking that's happening faster than you can say, "Help!" Here's the thing. By 2050, at least 32 major cities in the US, including New York, Baltimore, and Charleston could be partially underwater. And guess what? This one is mostly our fault. Scientists noticed that since 2007, some cities have been sinking into the ground between 0.04 and 0.08 inches every year. Charleston in South Carolina is pulling ahead in the worst way possible, sinking 0.15 inches annually. Sure, these numbers sound tiny and a bit ridiculous, but Charleston is barely 9 feet above sea level, and a little sinking goes a long way when the ocean is breathing down your neck. On really bad flood days, people there have to abandon their cars and basically swim home. This whole phenomenon is called land subsidence, and when you mix sinking land with rising sea levels, you get a disaster cocktail of flooded streets, salty farmland, ghost forests, and a lot of very cranky homeowners. And it doesn't stop with just homes. Infrastructure like bridges, roads, airports, and power plants, all things we rely on daily, are also at risk of serious damage. Flooded electrical grids and sunken highways could cause billions more in economic losses and create major safety hazards for communities. Now, let's be fair. Not everything is humanity's fault. Some of this trouble dates all the way back to the Ice Age. About 12,000 years ago, massive ice sheets covered the northern US. They were heavy, like seriously heavy. The weight pushed the land down, and when the ice melted, the ground didn't just pop back up like a trampoline. Instead, it started playing a weird game of geological seesaw. The places that were squished started rising, and the places that weren't got pulled down. This whole process, called glacial isostatic adjustment, try to say that 3 times fast. But of course, humans found a way to make it worse. Groundwater extraction is a major culprit. Think of it like pulling the stuff out of the mattress. After a while, the whole thing just sags. In places like California's Central Valley, the land is dropping by up to 8 inches a year because we keep pumping out water during droughts. In cities like New York, the problem isn't just water. Skyscrapers themselves are making it worse. Yep, turns out if you stack millions of tons of concrete and steel onto soft ground, it tends to flatten. And in case you're wondering, the total mass of New York City's buildings is around 1.68 trillion pounds. That's about the same as 3.5 million statues of liberty piled up. With so much weight concentrated over a relatively small area, the underlying soils have no choice but to compress over time. And if you thought it couldn't get messier, think again. We've been building dams, which stop rivers from delivering fresh sediment to coastal areas. That sediment is kind of like Mother Nature's way of fluffing the ground back up. Without it, coastal lands are compacting like an old sponge. Plus, when wetlands are drained for agriculture or construction, the peaty soil dries out and collapses. Honestly, it's like the ground just can't catch a break. Scientists also noticed that the areas that used to be lush wetlands are now among the fastest sinking spots in the country, especially along the Gulf Coast. Louisiana, for example, is losing about a football field of land because of this mix of subsidence and rising seas. So what's the end game here for us regular people who just want to live above sea level? Well, it's not looking great. Ghost forests, which are basically drowned woodlands, are popping up. Farmland is turning salty and unusable. And even sunny day flooding, where streets flood without any rain, is becoming a thing. Yikes! Meanwhile, over on the West Coast, California is not exactly winning either. San Francisco and Los Angeles are both sinking, which means that rising sea levels could hit them twice as hard and twice as fast. In some places like the Palos Verdes Peninsula, the ground has been sinking so fast, people over there might as well live like moles. So, is America turning into the next Atlantis? Probably not next week, but without serious action, like cutting back on groundwater pumping and planning smarter cities, at least 500,000 people are in serious danger. And the housing damage could easily rack up a jaw-dropping $109 billion by 2050. In the end,
While North America isn't about to sink like a poorly made souffle, it's definitely showing some cracks in the crust. So maybe let's ease up on groundwater pumping, rethink how and where we build, and invest a little more in keeping our feet dry. After all, if the floor really does become lava someday, we're gonna wish we had at least fixed the leaks first.
You're flying above Earth on the International Space Station at an altitude of 250 miles. You cast a glance out the porthole and your eyes widen in surprise. There's some kind of bright blue flash just above nighttime Europe. It's like there was an explosion of some strange substance there. Such a strange luminous event was spotted by a French astronaut from aboard the ISS. And it wasn't an explosion at all. It was lightning and was directed upwards. Until recently, this phenomenon was a kind of fairy tale among pilots. Scientists had heard their stories about lightning striking upward and about red and blue flashes at high altitudes too. But there was no definitive proof of the existence of these luminous events. But they do exist and are called sprites, elves, trolls, and ghosts. So how does ordinary lightning work? Masses of moist air in a cloud rub against each other and create static electricity. It would be almost the same if you danced in a wool sweater. It becomes charged with static electricity. And if you touch a metal doorknob, there's a discharge between your fingers and the door. There's your lightning. So a thundercloud builds up a strong negative charge. Sooner or later, a leader is born in the cloud. It's a bright thermo-ionized channel, or more simply, lightning. The leader moves toward the ground in steps of a few tens of feet, and it can accelerate to an average speed of 200,000 miles per hour. At that speed, you could make a trip around the Earth in just 7 minutes. But negative particles attract positive particles, and particles with opposite charges will tend to connect and compensate for each other. So, simultaneously with the negatively charged leader, the positive charge from the Earth begins its upward journey. The electric charge from the Earth connects with the negatively charged leader in one channel. This is when the brightest and loudest discharge happens. We call it lightning. It's this discharge that you hear as thunder. The main lightning doesn't strike from top to bottom, but from bottom to top. Yep, that is, the lightning is actually directed upward. It's as if the Earth is striking back at the thundercloud. And that charge can reach up to 30,000 amps. Your average wall outlet only has about 15 amps. And the record for the length of lightning is about 440 miles. That's more than the width of the state of Kansas. Meteorologists recorded such lightning in Brazil. It was a discharge between giant thunderclouds. And the longest lightning strike was recorded in Argentina. A single lightning strike there lasted 16.3 seconds. By comparison, you blink at 0.1 seconds. So we saw a regular lightning strike. The positive particles from the ground neutralize the negative particles in the cloud. But the cloud is still full of positively charged particles. They accumulate and wait for their time to create lightning. Once the charge reaches a critical point, the lightning cloud throws that charge dozens of miles upward. This is called a blue jet. It's exactly the same luminous event seen by a French astronaut aboard the International Space Station. The blue jets look like someone turned on a gas burner pointing upward. The positively charged blue jets neutralize at high altitudes with negatively charged particles, but people on the ground cannot observe blue jets. Thunderclouds obstruct the view, but they can be seen from an airplane. That's why, for a long time, commercial airline pilots were the only witnesses to this phenomenon. On board the ISS is also a great place to observe jets, as they are born at the very top of thick clouds and shoot dozens of miles upwards. But if you climb even higher, you can see this kind of bizarre lightning. It's a sprite. It looks more like a jellyfish, a cloud of red charge at the top and a bunch of little tentacles coming down. Now, normal lightning can have a temperature of about 54,000 degrees Fahrenheit, but you can touch a sprite with your hands. Unless, of course, you're afraid of a powerful electrical discharge. The sprite has about the same temperature as an energy-saving light bulb. All because sprites are born in the mesosphere. This is the layer of our atmosphere that starts at about 31 miles high. And it's the coldest place on our planet. On the ground level, where we live, the air is much denser. There are just more air molecules. They absorb heat from the sun's rays, and we feel comfortable. But the higher up we go, the fewer air molecules there are. At the altitude at which commercial airline planes fly, there's no longer enough air to accumulate that heat. You wouldn't even be able to breathe up there. That's why every airplane has oxygen masks for emergencies, and the temperature here is even colder than at the South Pole. In the mesosphere, there's almost no air, and the temperature here can be around negative 202 degrees Fahrenheit. And although the temperature of the lightning itself is high, in general, it's like if you poured a glass of boiling water into a huge barrel of cold water. The temperature won't change much. Sprites can only appear when paired with thunderclouds below. As a discharge occurs in a cloud, a sprite appears in the mesosphere. It tries to equalize the amount of charge in the atmosphere. So it's like these red flashes of lightning are trying to reach down to the thunderstorm. And a sprite itself can be as wide as the state of Massachusetts. And then there's a ghost. It can appear for the tiniest fraction of a second right after the sprite. It's a faint green glow, like an aurora. They were first discovered in 2014, and official confirmation by the scientific community only appeared in 2019. They're still poorly understood, but there's a hypothesis that ghosts have something in common with auroras. At least their color is green, and it may arise due to excited oxygen atoms. Sometimes we can spot trolls along with sprites. They look like pillars that support a sprite. It's a red glow at the end of the sprite's tentacles. The next moment, the troll releases a red streak down from itself. And if we climb even higher, we can see the elves. They only appear for 1 millisecond. It's a dim, flat glow that appears during thunderstorms in the ionosphere at an altitude of about 62 miles above sea level. Elves can be as wide as the distance between New York and Washington, D.C. Elves were first discovered during space shuttle flights in 1990. And these are pixies. They weren't discovered until 2000. Scientists observed bright, brief, luminous events for 20 minutes. Although they look like lightning striking inside a cloud, they have nothing to do with them. Pixies are smaller than 100 meters, which is about 330 feet. We shouldn't forget that any lightning is extremely dangerous for humans, and if you're caught in a severe thunderstorm, you need to leave its epicenter immediately. You can determine how far you are from the epicenter easily. The speed of light is much faster than the speed of sound. So, when lightning strikes, it takes a couple of seconds until you hear the thunder. So, you need to measure that interval. Lightning! Now count the seconds. Every second of thunder delay after lightning is about 1,150 feet. That's the distance a wave of sound travels in 1 second. So if the thunder delay after a lightning strike is 5 seconds, you're about 1 mile from the lightning. You can also tell if there will be a thunderstorm by the smell. The air before a thunderstorm seems unusually fresh. This is because the air currents bring in ozone molecules from the upper atmosphere. The same ozone protects us from harmful ultraviolet rays and transfers heat from the sun to the atmosphere. What we use to breathe is the oxygen of 2 atoms. Add 1 more and you get ozone. Ultraviolet light breaks down the 2 oxygen atoms and is absorbed by them. These broken atoms are then attached to the normal double oxygen atoms. When an ultraviolet beam strikes an ozone molecule, it knocks 1 oxygen atom out of the chain again. But ozone tends to regenerate, so the lost oxygen is reattached to other double atoms. But the ozone layer began getting damaged when humanity started emitting harmful gas into the atmosphere. Freon is to blame. It's the gas we were using in old refrigerators. The freon molecule contains harmful chlorine atoms. Ultraviolet rays knock this atom out of the molecule. Then that chlorine atom steals 1 oxygen atom from ozone, and we have a double oxygen molecule that can't regenerate and save us from the harmful ultraviolet rays. This causes a hole to appear in the ozone layer. The most famous ozone hole was over Antarctica, but when humanity banned the use of harmful chemicals, this hole began to recover. It's not that the hole will close completely, it will just return to the way it was before.
Yellowstone is the internet's favorite doomsday volcano. Maybe you heard the prediction. 1 super eruption, then a continent dusted in ash and temperatures going down. A perfect disaster movie scenario. Yet, geologists worry about a different kind of volcano. One that won't explode only once. It could rip the ground open, flood the entire continent with lava, and make the air unbreathable. And we know this because it happened before. Right now, researchers think there might be around 20 supervolcanoes scattered across the planet. Short story, we fear those. Long story, a major supervolcanic eruption could collapse modern society as we know it. A normal volcano can cause a local disaster. It can wipe out a city and turn a region into a no-travel zone. When Mount St. Helens exploded in 1980, it was huge. The eruption blew the top off a mountain and flattened forests like knocking down dominoes. It showed the world just how scary volcanoes can be. But in geological terms, it's nowhere near what a supervolcano could do. Mount St. Helens threw out roughly a third of a cubic mile of ash, enough to make a football field pile about 150 miles high. For comparison, a supervolcano could bury the entire state of Texas 5 feet deep, and Texas stretches about 800 miles. Volcanoes like St. Helens are mountains that build up over time, layer after layer, like nature stacking spilled wax. They erupt, they cool, they erupt again, and you end up with a cone that looks cool in photos. A supervolcano is like a hidden pit. It resembles a giant underground tank of molten rock covered in a thick slab of crust. Imagine the magma chamber like a huge underground room, and the ground above it is the ceiling. During a super eruption, cracks rip open across that ground and magma forces its way up through them, like steam blasting out of a pressure cooker. Ash and gas roar high into the sky. It can start in multiple spots across a wide area, not one neat hole. The magma chamber underneath can empty so violently that the roof above it collapses, the land drops, and what's left is a massive bowl-shaped scar called a caldera. And Yellowstone is the prime example. About 631,000 years ago, Yellowstone had a massive eruption and it left behind a giant caldera about 30 by 45 miles across. Now it's a national park, but it's also basically a footprint, like a warning. If Yellowstone erupted again, the first super hot clouds of ash and gas could blast outward and burn everything nearby. Then the ash would spread. And ash is not like the fireplace dust. It hurts to breathe, it wrecks engines, and it can shut down flights and machines. Regular volcanoes mostly hit the area around them with lava. A super eruption turns the air itself into a real danger. Ash spreads far and jams the things we depend on. High up, sulfur can turn into a thin haze that will block some sunlight. That can cool things for a while and mess with growing seasons, even far from the eruption. And winds can spread that effect well beyond the US. However, geologists worry about something even worse. A kind of eruption that can keep going in waves and cover huge regions in lava. It's called a large igneous province. It's not one volcano. It's a whole stretch of crust that starts leaking lava through long cracks over and over for a long time. Instead of one giant explosion, it's more like Earth turning on a lava faucet that just keeps going. Imagine a crack in the ground hundreds of miles long. Out of that crack comes a sea of lava. But this isn't the sticky, slow stuff you see in Hawaii. This is hot, runny, fast-moving lava, and it doesn't stop. It spreads, floods low spots, stacks into layers, and then does it again. And that's what makes LIPs scarier than a supervolcano. They drag on. They can erupt in repeated pulses over hundreds of thousands to a few million years. We have scars to prove it right here in the US. About 17 million years ago, the Pacific Northwest ripped open and created the Columbia River basalt. Lava did not just coat the land, it drowned it. The total amount that erupted was around 42,000 cubic miles. That's enough to cover the whole US in lava about 58 feet deep. But how can Earth produce enough lava to bury a mountain range? It's because the planet is still churning inside. Imagine Earth like a pot of thick tomato soup sitting on a stove. Earth's core is the stove, and it's extremely hot. The soup is the mantle, a thick layer of rock that moves slowly. Now and then, a massive blob of superheated rock rises from deep in the mantle, possibly from the boundary above the core. Scientists call this a mantle plume.
When it reaches the cooler crust, it spreads out, pushes upward, and when it breaks through, it does not build one neat mountain. It can open long cracks and feed eruptions in repeated bursts for a very long time. However, while lava burns everything in its way, it's not what wrecks the planet. The gas does. These eruptions release huge amounts of carbon dioxide and sulfur, and we can assume the consequences of that because it happened before, and not just once. About 252 million years ago, a massive LIP eruption began in what is now Siberia. It lines up with the worst extinction event in Earth's history, the Great Dying. Around 90% of species disappeared. Huge amounts of gas flooded the air and trapped heat. The ocean soaked up some of that gas and turned more acidic. Acid rain fell again and again. Life on Earth crashed. Scientists believe that in the last 500 million years, there have been 16 major extinctions like this, and that 15 of them line up closely with LIP timing. These geological formations changed Earth so many times, and scientists now wonder, what if Yellowstone and that massive lava flood in Oregon are actually a part of the same system? Look at Idaho from space, and you see a long, flat track across the state called the Snake River Plain. It points from the old lava flood region toward Yellowstone, like a trail. That path exists because Earth's surface moves. The outer layer is split into giant plates that slowly slide. Under Idaho and Yellowstone, a deep, hot zone keeps feeding eruptions. As the plate moves, the eruption zone shifts with it, leaving a long trail behind. That's why the rocks get older the farther you go from Yellowstone. It's the same heat source, just a moving target. And if you roll the plate's motion back far enough, that trail points closer to where the Columbia River basalts formed. That's why some geologists think the Northwest lava flood and Yellowstone could be connected parts of one long-lived system. Finally, if it's all part of one big apocalyptic system, is it time to pack the bags and flee to Mars? Will it happen again soon? Even if they share the same story, that does not mean the worst part is coming back soon. The lava flood chapter played out millions of years ago. Today, Yellowstone is simply where that deep heat shows up at the moment. And sure, it can erupt again, but the most likely eruption isn't some giant doomsday blast. It's a steam explosion, when super hot water flashes into steam and blows rock apart. Lava flows and smaller eruptions can happen too. The caldera-making nightmare is a rare one. If Yellowstone ever started building towards something big, it wouldn't be sneaky. You would see it coming. A lot more earthquakes than normal and the ground lifting faster than usual. The clearest right before signs would likely show up in the days or weeks before it. We cannot stop a planet-scale eruption. We can only watch for the warning signs and plan. But hopefully, if the planet decides to get rid of us, by the time it starts sending warnings, we'll already finish turning Mars into our new home.
Turkey is quietly tearing itself open, and no one noticed for decades. Scientists didn't just get a detail wrong, they misunderstood the entire motion of a massive chunk of Earth's crust. What they thought was sliding sideways is actually stretching apart, inch by inch, like the planet is slowly pulled in two. And once you see that rupture, you start noticing them everywhere. To understand why this shocked geologists so badly, picture Earth's crust like a cracked shell floating on something hot and squishy underneath. Those cracked pieces are tectonic plates. They move a few inches per year, which sounds tiny, but over millions of years, it reshapes continents. Turkey sits in one of the most uncomfortable places on Earth, squeezed between three huge plates: Eurasia to the north, Africa to the south, and Arabia pushing in from the southeast like an elbow in a crowded bus. For decades, scientists believe Turkey survived this squeeze by sliding sideways. This type of movement is called a strike-slip fault, which basically means two chunks of land grind past each other like hands rubbing together. Turkey has famous ones, like the North Anatolian Fault, which produces horrible earthquakes. That model felt neat and logical. Pressure comes in, land escapes sideways. Problem solved. Or so everyone thought. But geology doesn't always follow neat models made up by humans. There is a long fracture running beneath salt flats and farmland under central Turkey. It never behaved like the dangerous sideways faults, so it got less attention. Then researchers from Curtin University decided to look closer. And instead of watching earthquakes, they watched lava. Ancient lava. Lava that flowed across the fault thousands of years ago, cooled into solid rock, and later ruptured apart. There are tiny crystals called zircons inside that lava. They're basically nature's stopwatches. Zircons trap radioactive elements that decay in a predictable rate, so scientists can tell exactly when the lava cooled. When they matched lava chunks on opposite sides of the fault and measured how far they drifted apart, the team managed to reconstruct how the fault was moving over thousands of years. It turned out that the fault wasn't sliding sideways at all. It was slowly and steadily pulling apart, just a fraction of an inch per year. That's thinner than a grain of rice, but over geological time, it's massive. This type of fault is called an extensional fault, which means the crust stretches until it thins and breaks. In simple terms, Turkey isn't just being squeezed, it's being torn open. And as if that wasn't dramatic enough, the story gets worse. Other studies show that parts of Turkey's crust aren't just stretching, they're dripping downward into the mantle. When dense chunks of crust get heavy enough, they peel off and sink like blobs of wax in a lava lamp. Scientists call it lithospheric dripping, and this process is basically Earth quietly losing pieces of itself. When that happens, the surface above weakens. The land rises, sinks, fractures, and rearranges. Earthquakes don't always need plates to slam together. Sometimes the ground fails because its support system melts away from below. That's why Turkey's geology now looks less like a solid slab and more like stretched taffy over a fire. Turkey isn't alone with the tectonic drama. Africa is unzipping itself so slowly that no human will ever wake up to a brand new ocean outside their window, yet fast enough that scientists can measure it happening right now. Deep beneath East Africa, the ground stretches and thins. Over millions of years, that constant stretch doesn't just rupture rocks, it rewrites geography. And it can literally create an ocean where solid land once stood. All of this focuses on something called the East African Rift System. This rift runs thousands of miles across places like Ethiopia, Kenya, Tanzania, and Mozambique, and it ranks among the largest rift zones on Earth. A rift zone is where the planet's crust is being pulled apart instead of being squished together. Africa doesn't just have a rift zone, but one of the most extreme versions anywhere, and it's been stretching for tens of millions of years, like a slow-motion disaster movie. And the continent isn't one solid piece anymore. It's splitting into two massive tectonic plates. The Nubian plate sits to the west, the Somalian plate to the east, and they're drifting apart at less than an inch per year, which sounds like a joke until you realize your fingernails grow at about the same speed. But just like in Turkey, this tiny movement adds up over millions of years. Back in 2018, photos of a massive rupture in Kenya caused chaos over the internet, and headlines panicked everyone with the news that Africa was splitting in half. The image looked intense, but it didn't mean the continent snapped overnight like a broken cookie. A much deeper process has been going on for about 25 million years already. And if we could jump another 5 or 10 million years into the future, we'd probably watch the crust stretch so thin that seawater finally rushes in and fills the gap. While Africa is tearing apart vertically, like a slow zipper, India could be splitting in a totally different way, horizontally into two giant layers, each about 60 miles thick, right as it crashes into Eurasia. And this collision is what gave us the Himalayas and the massive Tibetan plateau sitting behind them like a high-altitude backstage area. Everyone agrees on the basics. India has been creeping north for over 60 million years at about the speed your hair grows, slamming into Eurasia and forcing rock upward until it turned into the tallest mountains on Earth. What no one fully agreed on was how Tibet got so insanely high. Some scientists thought India was too buoyant to sink and just slid underneath Eurasia. Others imagined the plate buckling like a sheet of paper pushed into a wall. Then a third idea showed up and changed the vibe completely. This new theory says the Indian plate is delaminating, which means its top layer peels away and props up Tibet. At the same time, the heavier bottom layer sinks into the mantle, the hot semi-molten layer beneath Earth's crust. Scientists can't drill that deep to check, so they followed a clue instead: helium leaking from Tibetan hot springs. Helium-3 is incredibly rare and mostly comes from deep inside Earth, and helium-4 forms closer to the surface. When researchers measured gases from hundreds of springs, they found helium-3 leaking out in northern Tibet. It means that the mantle sits dangerously close to the surface there. Farther south, that signal disappears. So it most definitely means that the plate hasn't fully split yet. But we have earthquake patterns that line up with the same story, so it looks like India isn't just pushing mountains up. It's peeling itself apart from the inside while doing it. All these tectonic processes fit in well with the new massive global stress map. It shows where the planet is holding it together and where it's dangerously close to rupturing. Scientists built it from over 100,000 real stress measurements taken from boreholes, earthquakes, and field tests, which is more than double what we had less than a decade ago. Stress here means the invisible push and pull forces inside Earth's crust, the same forces that quietly load faults for years before one bad day turns into an earthquake. This map doesn't just help explain earthquakes, but also not to mess things up ourselves. If you drill a tunnel, inject carbon underground, or build a geothermal plant without knowing which way the rocks want to snap, you're basically poking a sleeping dragon. Engineers use this stress data to decide how to angle wells and tunnels so they don't accidentally cause failures. Basically, we're finally getting a live dashboard for Earth's breaking points, and that's a big deal when you live on the surface of a restless planet. For a long time, we treated continents like rigid boards floating on soup. Now they look more like stressed muscles, flexing, tearing, healing, and tearing again. It shows that the planet under your feet isn't finished. It's still under construction. Tunnels, metro, underground systems, and even secret passageways to the houses of the rich and famous. Why else do we need tunnels, you may wonder? To hide. Many cities have underground tunnels and even underground doppelgangers. Now let's make it clear. Those passages are normally not connected, contrary to the popular rumor claiming that it was possible to get from Scotland to Turkey using underground passageways built around 5,000 years ago. I mean, it sounds insane even today. Imagine building it back in the day. These tunnels have an official name, the Erdstall Tunnels, and they were most likely built in the Middle Ages. However, we still don't have the exact information about the date. The highest concentration of those tunnels are in Bavaria, Germany, but there are many of them in Great Britain and France too. Erdstall tunnels, a unique type of earthen passage found globally, are characterized by their narrow, oval-shaped corridors and tight choke points, known as schlups, or slip-outs. Despite speculation, their purpose remains a mystery. However, some of those tunnels have fireplaces and even vents, which might mean those were used primarily for shelter. Dating back to the Middle Ages, possibly as early as the 12th century, Erdstall tunnels lack archaeological signs and historical records. So it's not a surprise that there are many rumors about their use. Some scientists are sure those were storage spaces, though their narrowness makes this impractical. Another idea is that they provided hiding spots for farmers during tribal raids. However, their single entry point raises doubts about their effectiveness in evading threats. Now, if you're feeling like Indiana Jones and want to venture into those tunnels, you're in luck. A few structures, like the Erdstall Radkobluken in Austria, welcome visitors to explore these enigmatic structures. Most of them are closed to the public eye, though. The origins of Erdstall tunnels remain largely unknown, just like their real functions. And if you think,
Hey, it's the 21st century here. We can study pretty much everything. Well, you're wrong. What makes these tunnels hard to study are the tight confines. Traditional surveying methods often prove inadequate in such spaces. To solve this problem, scientists use a handheld device that integrates an RGB camera, a gyroscope, and high-resolution depth sensors, allowing them to capture intricate details of the tunnels. They also use modern techniques like 3D surveying in hopes of uncovering the true origins and purposes of those tunnels. One hypothesis even suggests they may have been poorly conceived dwellings, abandoned when their inadequacies became apparent. Still, not everyone quite agrees with this idea. Other theories suggest they served spiritual purposes, while the most intriguing idea speculates that those tunnels may be remnants of extraterrestrial civilizations. Experts believe they may have been used for practical matters, such as granaries or hiding spots from looters. As we don't have exact info on who built it and when, it may be pretty much anyone, even a sloth. Nope, I'm not a lunatic. Sloths can build giant tunnels. Check this out. In 2009, a farmer in southern Brazil was driving his tractor through a cornfield when it suddenly sank into the ground. He quickly discovered he had broken through the top of an underground tunnel. When researchers came to investigate, they found a tunnel around 6.5 feet high and the same 6.5 feet wide, extending about 50 feet long right beneath the farmer's house. When they looked closer, they instantly saw deep claw marks on the walls. That was the proof the tunnel wasn't human-made. So that thing the farmer uncovered was a megafauna paleoburrow, a prehistoric tunnel dug by ancient creatures like giant ground sloths or giant armadillos from over 10,000 years ago. I know, it's hard to imagine those beasts, but let me help you. Take a hamster. Now, increase it to the size of an elephant. Don't forget, this 13-foot-tall hamster could also walk on two legs. During their time, around 15 million to 10,000 years ago, many species of sloths and giant armadillos roamed the Americas, some even digging similar tunnels. Today, many of these tunnels are filled with sediment, though some remain clear, similar to the one the farmer discovered. This 2009 find sparked significant interest, leading to the discovery of over 1,500 paleoburrows across southern Brazil, making it the era with the highest concentration of such sites worldwide. But no one knows exactly why there are so many of them in southern Brazil. While some paleoburrows exist throughout South America, none have been found in North America, which is weird since those huge sloths roamed the entire continent. The exact purpose of these large tunnels remains a mystery, but scientists believe they may have served as nursing spaces, temperature regulation, or hibernation areas. Tunnels likely developed over centuries as successive generations of sloths and armadillos expanded them. Now, let's take a look at fugus. No, not the Japanese fatal delicacy, and no, not a town in New Guinea. To see them, we gotta travel to the UK. So fugus are underground structures too, but they don't look exactly like tunnels. They are dry stone structures. They look as if a cave had been decorated with stones from the inside. There are only around 15 of them found so far, and most of them are located in Cornwall. According to the estimates, those tunnels were built about 2,400 years ago, and they're still in pristine condition, which is truly fascinating. I mean, back in the day, people had no cool machinery whatsoever, yet their structures still last. And if you dare to buy an apartment today, well, chances are you won't be too happy about the quality. Going back to our fugus, there's nothing extraordinary about their supposed purpose. They could be used for spiritual purposes, as a place to hide, or a food storage. The latest application, though, is a bit weird. I guess it's not a secret for anyone that England is famous for its excessive humidity. And if you want to store your food properly, you gotta avoid the humidity at all costs. Otherwise, say welcome to mold and fungi. But ancient people weren't dull-witted at all, or they wouldn't have survived, and you and I wouldn't be around now. So they might have adapted those fugus to store just some products, those that already had natural molds in them, assisting in the preservation of perishable food, like milk, butter, and cheese. But hey, those are just speculations. The true reason why they were built remains unknown. What makes fugus unique is that they are intentionally built tunnels, not just excavated mines like those in Wales. They were crafted by digging deep trenches, lining them with stone slabs, covering them with capstones, and then filling over them, all of which took significant time and effort. Still, no matter how hard those were to construct, cities around the globe are often built over intricate tunnel systems, each unique to its location. For instance, Paris is famous for its extensive underground quarries, which were abandoned years ago, but still pose a risk of collapse in certain areas above. London boasts one of the largest tunnel networks in the world, including many that were specifically created for military purposes. In New York City, there are rumors of secret tunnels, while Los Angeles has old tunnels from the Prohibition era used for speakeasies. Many other cities also have their share of enigmatic tunnels, and surprisingly, Florida is no exception. It happened in the year 2011 in Ybor City. Near a former post office, flooding uncovered something weird, a section of an unknown structure. Back then, people didn't pay much attention to that, so it took another 7 years to discover something truly fascinating. This historic neighborhood was founded in the 1880s, but it remained unknown until 2018 that it also has a hidden tunnel network. We only learned of it because of renovation work. The exact purpose, of course, is unknown, but most scientists are pretty sure that they serve to connect to early gaming spots and the port of Tampa. Figuring out how extensive the tunnel network is tricky. In 2018, a historic home in Seminole Heights revealed locked doors leading to tunnels from the 1920s. One local even said he traveled through a tunnel for 20 minutes. Rumors suggest some tunnels connect to the Hillsborough River and Ybor City. Research is ongoing, but no new info has emerged yet.
It was April 2025 when geologists went back to Yellowstone's Norris Geyser Basin for the first time this year. And while doing their usual check, they realized that something was different this time. Where there used to be just a boring patch of ground, now there was a giant hole, about 13 feet wide, filled with weird, milky, light blue water. Everyone was terrified. Was it the sign that the Yellowstone supervolcano was ready to erupt? If so, it would be a worldwide disaster, the kind that destroys cities. According to the U.S. Geological Survey, if such an eruption occurred, the after effects would be felt all over the world. To start, the areas immediately surrounding Yellowstone would experience pyroclastic flows. That's the lava that erupts out of a volcano, including a high-density mix of volcanic gas, ash, pumice, and hot lava blocks. Those flows would destroy everything they touch, and an eruption of Yellowstone would send them into Wyoming, Idaho, and Montana. Areas further away from Yellowstone would escape the flows, but they would experience falling ash. It would come down heavily in the states closest to the epicenter. The ash would be especially dangerous for anyone breathing it in. The weight of the ash would also pose a serious threat. It would smother crops and collapse buildings as it piles up. Tragic consequences would be countless, but we'll talk about them later, because soon after the discovery, the weird pit surprised even experts. Geologists found rocks scattered everywhere. Some were about a foot across, and all of them were dusted with gray mud. This mud matched the walls of the new spring. It was like the place had simply exploded, but nobody had actually seen it happen. The team checked old satellite images to figure out when it appeared. In December 2024, the ground was totally normal. By January 6, 2025, a little dip had formed, and by February 13th, that water-filled hole was finally there. But the weird thing was that the sensors that usually pick up major hydrothermal explosions didn't detect anything. There was no giant blast or warning signs. Later, it turned out that this puzzling opening in the ground hadn't just popped up in one huge explosion. Instead, it formed from a bunch of smaller bursts over time. Little explosions first threw out rocks, then mud, and eventually created the pit. With time, it filled with silica-rich water. That was a huge relief for everyone. Yellowstone sits on a supervolcano, and its big explosions are a nightmare scenario. Luckily, this time, it was just a slow-building, small-scale explosion. It was dramatic, sure, but totally manageable. You see, Yellowstone National Park is full of geysers, hot springs, and all kinds of natural landscapes. But under the surface, things get incredibly intense, all because of the supervolcano. Now, supervolcanoes are often extremely large. They often have no cone at all, since they're typically the remains of gigantic magma chambers. Once, those chambers flared up, leaving behind a caldera. They're usually located over hotspots. It's no surprise that supervolcanoes can produce super eruptions, and when they do it, they blow more than 240 cubic miles of ash, molten rock, and hot gases up into the air. In other words, 4 super eruptions could fill the Grand Canyon to the brim. Supervolcanoes form when huge volumes of scorching hot magma escape from deep underground. This magma rises close to the surface but can't break through Earth's crust. So, a pressurized pool of bubbling magma gathers at a depth of only several miles. The pressure keeps growing because more and more magma is trying to get to the surface. And then, bang, a super eruption occurs. Now, back in 2015, researchers at the University of Utah mapped out the main magma chamber of the Yellowstone supervolcano and were shocked by its size. And then, they found another one below it. Together, these underground magma pools could hold enough molten rock to fill the Grand Canyon 11 times. All that magma pushes up on the ground above, which is why Yellowstone rises about an inch or two every year. That slow lift might not sound like much, but combine it with the fact that Yellowstone is still an active volcano and has a volcanic explosivity index of 8, and it's enough to make you wonder what could happen if things went south. And yes, Yellowstone has indeed been a bit jumpy in recent years. In March 2023, there were 354 earthquakes in the area. Most were tiny, but the biggest hit a magnitude 3.7, part of a swarm of 106 quakes. Now, before you freak out, experts from the Yellowstone Volcano Observatory say there's no need to panic. No eruption is coming anytime soon. Volcanoes don't stick to a schedule. Just because Yellowstone hasn't erupted in a long time doesn't mean it's about to blow. The park is stable for now, but scientists are keeping a close eye on everything underground, the quakes, the rising ground, and even temperature changes, just to be safe. The superhot plume of magma, a hotspot under Yellowstone, has been churning for 17 million years. The Earth's crust slowly moved over it, making the hotspot leave a trail of volcanoes stretching more than 450 miles along the Snake River Plain. Most of those ancient ones are now buried under layers of lava and sediment. In just the past 2.1 million years, Yellowstone has unleashed 3 cataclysmic eruptions, so massive they managed to reshape the land. Each explosion sent pyroclastic flows, rivers of searing hot rock, ash, and pumice racing outward for miles. The debris piled up in layers hundreds of feet thick, some forming solid lava-like rock. When those eruptions emptied the underground magma chambers, the roof collapsed, forming the massive calderas we see today. Even after those mega eruptions, Yellowstone didn't stop. Between 180,000 and 70,000 years ago, enormous rhyolite lava flows, sometimes over 144 cubic miles, poured out. Some flows followed north-south vent lines. The West Yellowstone flow erupted around 110,000 years ago. The Nez Perez Creek flow followed 160,000 years ago. If you stand at Madison Junction on the caldera's northwest rim, you can see it, a cliff that formed when the Lava Creek Tuff eruption collapsed the land 640,000 years ago. And inside the caldera, you'll see the hardened lava flows snaking across the floor. Figuring out when a supervolcano might blow is like being able to read nature's warning signals. Thousands of years before a massive eruption, the heat underground starts building, and the magma chambers become like ticking pressure cookers. Little signs start showing up. Gas bubbles escape as the pressure shifts, and earthquakes shake the ground. The land above slowly rises. Cracks appear. Hot springs and geysers start acting up, heating even more than usual. Now, what would happen if Yellowstone erupted? Remember those pyroclastic flows we talked about before? They can contain two parts: the lower flow of the hot lava that moves at ground level, and a cloud of ash that follows above the lava level. So the two of them would devastate huge areas. The ash would even reach Europe within 3 to 4 days of the eruption, but it wouldn't be so bad there. After that, it would only take around 2 to 3 weeks before cooler temperatures set in around the globe, all thanks to the sulfur gas that would get to the upper atmosphere after the eruption. Scientists predict that global temperatures would drop by up to 10 to 12 degrees. These consequences could last for 6 to 10 years, putting an end to monsoons, which could cause widespread famine in Asia. Scared? Well, don't be. The good news is that scientists don't believe that the sleeping giant under Yellowstone National Park will wake up in our lifetime. Experts say the next Yellowstone eruption won't likely happen for hundreds of thousands of years. And even then, it may not be that bad, because scientists have discovered that the magma lurking within Yellowstone is actually split up amongst 4 different chambers. Not only that, but some of the reservoirs of magma are likely to cool down and solidify, lessening the chances of an eruption. So, while an eruption does sound like it would change the landscape of the world, it's very unlikely to happen anytime soon.
While you're watching this video, pieces of continents are slowly breaking off from below and are pulled down into the oceanic mantle, a hot, mostly solid layer that moves slowly under the seafloor. As soon as these fragments reach the mantle, they can trigger volcanic eruptions in parts of the ocean where there are no volcanoes. Plus, when continents break apart, it happens not only at the surface, but also deep down. But more on that later. This process can continue for tens of millions of years. The new study shows that Earth's insides are even more dynamic than we thought. It also explains why many volcanic islands, including Christmas Island in the Northeast Indian Ocean, contain unusually high levels of certain chemical elements. The thing is, these elements are normally only found in continental crust. Well, scientists did suspect that these elements showed up because some powerful forces deep inside the Earth took old, recycled pieces of rock and mixed them into the mantle. This process works a bit like when you mix together ingredients for cake batter. But before, researchers believed those elements came from 2 main sources: sediment that sank into the mantle as oceanic plates got pushed down, or from mantle plumes. Those are columns of hot rock rising up from deep inside Earth. However, these explanations don't fit all observations. In some volcanic areas, there's almost no sign that the crust has been recycled. In other places, the mantle seems to cool and too close to the surface to be affected by the rising hot rock. Scientists used to wonder how this could happen. Now we know that some of the material in those regions comes from pieces of continents that sink deep into the mantle, and these pieces affect the volcanoes that form above. The new study also suggests a curious idea. Continents don't just break apart at the surface, they peel away from below too. and this can happen over much greater distances than scientists thought before. Researchers used simulations to figure out how continents and the mantle behaved when stretched by tectonic forces. Their work is built on earlier research showing that when continents split, deep, powerful forces inside our planet create a mantle wave. This wave moves along the base of the continent at depths of about 90 to 125 miles. The wave moves extremely slowly, about a millionth of the speed of a snail, and gradually strips material from the roots of the continents. These peeled-off fragments are then carried sideways, sometimes more than 620 miles, into the oceanic mantle. Once there, they can trigger volcanic eruptions in the ocean for tens of millions of years. The research also shows that the mantle continues to feel effects of continental breakup long after the continents themselves have separated. Even after a new ocean basin forms, the mantle keeps moving, reorganizing and transporting enriched material far from where it originally came. To make this conclusion, researchers studied geochemical data from different parts of the Earth, including the Indian Ocean Seamount Province. That's a chain of volcanic formations that appeared after the supercontinent Gondwana had broken apart over 100 million years ago. Their computer models and chemical tests showed that right after the supercontinent Gondwana broke apart, a lot of magma with unusual chemicals pushed up to the surface. Over millions of years, this chemical signature slowly faded as less material came up from under the continent. The most unexpected discovery is that this happened without any help from those deep, hot columns of rock scientists used to think were needed. Now, to get an even clearer picture, let's sneak a peek into our planet's insides. Earth is about 4.6 billion years old. It was born from a huge cloud of dust and gas that slowly cooled, shrank, and hardened into the planet we know today. As it cooled, heavy metals like iron and nickel sank to the center, and lighter, rocky materials floated upward. This created the Earth's layered structure, with each layer having its own unique properties. The crust is like Earth's skin. It's our planet's outermost layer made of solid rock. It's broken into huge pieces called tectonic plates that slowly drift over time. There are two kinds of crust: oceanic crust and continental crust. The oceanic crust is about 4 to 6 miles thick. It's covered with a thin layer of sediments like sand, clay, and shells. Below that are dense rocks like basalt, rich in magnesium. As for the continental crust, it's thicker than oceanic crust and is located under continents. It's made of lighter rocks than oceanic crust. Beneath the crust is the mantle. It makes up more than 75% of Earth's volume. The top of the mantle is pretty rigid, but deeper down it becomes soft and partially molten, which allows it to flow slowly. This flow is what moves the tectonic plates. At the center of the Earth lies the core. It's made mostly of iron and nickel and has two distinct layers, the outer core and the inner core. The outer core is a liquid layer of iron and nickel. It's insanely hot, up to 10,800 degrees Fahrenheit, as hot as the surface of the sun. The outer core also generates Earth's magnetic field, which protects us from harmful solar radiation. The inner core is solid because of the crushing pressure inside the planet. It's also made of iron and nickel. Now, the Earth's outer shell, called the lithosphere, is made up of the crust and the uppermost part of the mantle. It's broken into large pieces, called tectonic plates. There are a few super large plates and many smaller ones. 6 of the major plates are named after the continents they carry, like the North American, African, and Antarctic plates. But even those smaller plates play an important role. For example, the tiny Juan de Fuca plate is responsible for many of the volcanoes in the Pacific Northwest of the United States. The plates are moving like a jumble of old conveyor belts. They move very slowly, about 1 to 2 inches per year.
But over millions of years, this movement shapes the face of our planet. Most earthquakes, volcanoes, and mountain building happen where plates meet, pull apart, or slide past each other. There are three main types of plate boundaries: convergent, when plates move toward each other; divergent, when plates move apart; and transform. That's when plates slide sideways past each other. When tectonic plates collide, the crust crumples and buckles, forming mountain ranges. About 55 million years ago, India crashed into Asia, slowly creating the Himalayas, the tallest mountains on Earth. The collision continues today, so the mountains are still rising. Mount Everest, the highest point on Earth, may even grow a tiny bit taller over time. At some convergent boundaries, an oceanic plate dives under a land plate in a process called subduction. The land above lifts up, forming mountains, and the sinking plate melts and triggers volcanic eruptions. This is how some mountains in the Andes of South America were formed. When two oceanic plates collide, one usually slides beneath the other, creating deep ocean trenches, like the Mariana Trench in the North Pacific, the deepest point on Earth. These collisions can also form underwater volcanoes that eventually rise above the ocean and turn into island chains, such as Japan. At divergent boundaries, tectonic plates move away from each other. In the oceans, magma from deep in the mantle rises to fill the gap. This creates underwater mountains and volcanoes along the seam. This process renews the ocean floor and slowly widens the ocean basins. By the way, a single mid-ocean ridge system connects all the world's oceans, making it the longest mountain range on Earth. On land, when plates pull apart, they form giant valleys, such as the Great Rift Valley in Africa. If this stretching continues over millions of years, East Africa could split off to become a new landmass. One famous example of transform boundaries is the San Andreas Fault in California. Unlike convergent or divergent boundaries, transform boundaries usually don't create mountains or oceans, but the grinding motion can cause powerful earthquakes, such as the 1906 earthquake that destroyed much of San Francisco. 7,500 years ago, the Pacific floor collapsed. Massive landslides buried the seabed in seconds. Fast forward to today. Robot subs have examined the place. Scans have revealed proof of at least 10 distinct cyclical megaquakes. Now, researchers warn, the plates are still locked and building pressure, even today. If they start moving, that could trigger new red alert earthquakes and send disastrous tsunamis toward the coast. Let's look at the map. The fault here is like a giant zipper. It's over 600 miles, stretching from Northern California to Canada. It's called the Cascadia Subduction Zone, and it's a part of the Ring of Fire. You know, the famous giant horseshoe around the Pacific that can serve as your where-to-go reminder if you're into volcanic and earthquake tourism. One of Cascadia's biggest events happened around the year 1700. There are no local written records of it, but there is a story. A well-known indigenous legend tells of an epic battle between a thunderbird and a whale. In the story, the thunderbird's wing beats make the ground shake. The whale's thrashing sends seawater flooding inland. The thunderbird wins by finally grabbing the whale and slamming it back down, shaking the land itself. Many researchers believe that this legend originated from the real earthquake of 1700. But we don't just have cool myths to give us the full picture. In the early 1700s, samurai officials recorded waves flooding villages and rice fields. But nobody felt the earthquake that must come first. That's why they nicknamed this event the Orphan Tsunami. But it did have a parent, and it took scientists 300 years to finally connect it back to Cascadia. To see Cascadia's past, researchers sent robot subs to scan the bottom in crazy detail. They expected to see a simple crack, but what they found looked more like giant underwater steps. Some of those steps are about 33 feet tall, like a 3-story building. That only happens when a big piece of the seafloor snaps off, breaks loose, and slides all at once,
not slowly. When that happens, it kicks up a mud avalanche. Picture a jar of dirt and water. Shake it hard, and a fresh layer settles at the bottom. Each layer is basically a timestamp from a huge quake. When scientists counted and dated them, they found 10 separate megaquakes that hit one after the other over thousands of years. That means that Cascadia doesn't let pressure out little by little. It stays stuck for a long time, then suddenly breaks out violently. That pattern is why the Cascadia subduction zone is considered one of the scariest fault systems in North America today. So what's actually happening down there? The plates aren't sliding smoothly, they're stuck. And while they're stuck, the coastline is getting quietly bent out of shape like a ruler you're flexing in your hands. It doesn't look dramatic day to day, but it's been loading up for centuries. When that tension finally snaps, the coast will instantly drop. Geologists call this co-seismic subsidence. We're talking about the ground plunging 6 to 8 feet vertically in a matter of minutes. Imagine standing on a beach. The shaking stops, and you realize the ocean is rushing in. Not just because of a wave, but because the land you're standing on has physically sunk below sea level. That one move is enough to shove the seafloor out of position and force the ocean above it to react. Cascadia can produce a magnitude 9.0. That's top tier, categorized as the most destructive natural event that can happen. It can shake the ground for minutes, pushing and pulling everything back and forth until buildings and bridges start falling down. A 9.0 class quake also means the seafloor is vibrating and shifting, lifting in some spots, dropping in others, all in one sudden motion. A tsunami starts when the seafloor moves and pushes a huge amount of water out of the way. If the bottom suddenly lifts or drops, the water above it gets displaced instantly. That water has to go somewhere, so it races outward in every direction. Out in deep water, that wave is rarely tall. It spreads out across a long distance, so it can pass under ships without anyone noticing. The danger is speed. In the open ocean, tsunamis can travel around 500 to 600 miles per hour. That's like traveling from New York to Detroit in 60 minutes. Eventually, the ocean starts to pile up, getting taller by the second. Near shore, it can stack up to tens of feet, and in extreme cases, it can run up to 100 feet on land. It swallows the coast, then drags everything back to sea with a violent tug before the next hit arrives. But that's not all. When the fault snaps, it often triggers massive underwater landslides. When a huge chunk of seafloor collapses, it can shove water locally, like dropping a boulder into a tub. In the Cascadia subduction zone, you aren't just dealing with the earthquake's kick. You're getting a 1-2 punch from the shifting crust and the crumbling slopes combined. On parts of the Oregon coast, emergency experts say the shaking could last 5 to 7 minutes, long enough to realize what's happening and still won't be over. Then comes the scariest part. In some places, a tsunami can hit in 15 to 30 minutes. Remember, the earthquake is a warning. If you're on the coast and you feel strong, long shaking, you do not need to wait for a text alert or a siren, or someone on the news to yell tsunami. During the tremors, the basic recommendation is to literally drop to the ground, cover, and hold on, staying away from windows and chandeliers that can fall on you. As tempting as it is, we shouldn't stop to make a reel out of the situation. Before anything happens, make one decision while your brain is calm. Pick the closest high ground and go for it. Not somewhere uphill, an actual spot. If you ever needed a reason to learn your neighborhood, this is it. Your instinct might say, get into the car and drive. But don't. Roads are probably jammed and bridges could be damaged. People who live on the coast already know to keep it practical, with shoes on the bed and a go bag prepared just in case. The danger doesn't end with the first impact because the tsunami waves, well, they come in waves. The initial hit is rarely the largest, and the ocean can continue to pulse in and out for hours. This creates a violent tug-of-war. The receding water acts like a massive vacuum, dragging anything caught in the backwash out to sea. Japan's 2011 disaster is the most recent vivid example of what a magnitude 9.1 can do. The seafloor shifted in a single massive heave, and minutes later, the ocean literally rearranged the coast. A huge wall of water crashed inland, reaching over 100 feet high in some spots, and turning the coastline into a conveyor belt of debris. It was like water turned cars into giant bowling balls and shipping containers into massive metal bricks, smashing ports and drowning low-lying airports and electrical substations. Finally, what do officials say about the timeline for the possible next disaster hitting Cascadia? Well, they can't give us precise dates, but they did announce some odds. For the biggest, scariest earthquake possible, the United States Geological Survey says there is about a 10% to 15% chance it'll happen in the next 50 years. Chances for a quake that isn't the mega version are 1 in 3 in the next 5 decades. Those odds are actually pretty high. But here is why it isn't all that grim. Scientists know this isn't random. Cascadia has a pattern, and patterns are what preparation runs on. We already know how to build for big shaking, and we're getting better at spotting where stress is building. It doesn't mean we can stop the earthquake, but it means we're getting way better at knowing what to expect. In the meantime, just keep a go bag by the door and maybe take a walk around your neighborhood every once in a while. On March 24th, European skies were dominated by a glowing, insane blue spiral. The eerie sight kept growing, expanding, almost like the whole Earth was about to get sucked into a vortex. And after a couple of minutes, poof, it suddenly disappeared. Even though it looked like some kind of extraterrestrial tech, there's actually a very human explanation behind it. Photos of this strange swirl started popping up all over Europe, with people sharing them from countries like the United Kingdom, France, Norway, and Germany. But if we really want to figure out what happened, we have to look all the way over to the United States. Turns out, on that same day, SpaceX's Falcon 9 rocket was launched from Florida at around 1:50 in the afternoon local time. So while most people in the US saw clear skies after the launch, it actually caused that strange anomaly in the European skies. And that happened because Falcon 9 is a reusable rocket. So, after launching into space, it releases what is called its payload. And by that, I mean whatever it is carrying, like a satellite. After completing its mission, the rocket itself turns back toward Earth. As it does, it ejects any leftover fuel, which instantly freezes due to the high altitude, forming a spiral pattern because of the rocket's movement. Light then reflects off the frozen fuel, making it visible from Earth. Basically, that's what the blue spiral was, leftover fuel released by the rocket in space. So, should we be worried down here on the ground? I mean, is it dangerous? Well, no. It's not like it was some kind of spacecraft accident. It's just leftovers and light. And this is totally normal for the Falcon 9 rocket. Even though it went viral this time, the same phenomenon was spotted about 4 years ago. Back then, people speculated all kinds of things, like a swirling galaxy moving across the sky, or even an unidentified, unexplained flying object. But nah, it was just one of Elon Musk's space toys. Speaking of which, his space agency is also behind another eerie sighting that's becoming more common. On clear nights, many people have reported seeing a strange string of lights moving quickly in a straight line, almost like a train of stars. Those aren't drones, and they're definitely not perfectly organized shooting stars. These strange lights are actually Starlink satellites from SpaceX. You know, that project that beams high-speed internet from space using thousands of tiny satellites, basically turning the entire planet into a giant Wi-Fi zone. But wait, satellites don't have lights on them. So how is it possible that they look so bright at night? Well, basically, what we're seeing is the sun reflecting off the satellites as they travel through their lowest orbit.
and they're only visible if the sky isn't too bright. What's really impressive is that you can see this same event more than once on the same day. That's because Starlink satellites travel at a staggering speed of 300 miles per minute, and they complete one full orbit of Earth every 90 minutes. So, doing the math, that means you could spot those satellites within 2 hours of a previous sighting. Without a doubt, the beginning of the year was busy for skywatchers in the United States. In February, they got to see this stunning, cloudy jellyfish shape taking over the sky. What do you think it is? If you guessed another thing related to SpaceX, you're right. This is another art created by a Falcon 9 rocket. This time, it happened because the rocket was launched during the evening twilight. The light from the setting sun bounces off the rocket's smoke trail, creating this amazing effect. Now, let's move on to Italy, where another creepy event occurred. It was a stormy night, and suddenly, way up in the sky, a giant glowing red ring flashed for just a split second. Nope, it was not an extraterrestrial portal. This is something called an ELV. This happens when a powerful lightning strike sends out an electromagnetic pulse that hits the ionosphere, which is a super high up layer of our atmosphere. When this happens, nitrogen atoms up there get excited and glow red, creating a massive but super quick light show. Another red phenomenon happened in Scandinavia, but instead of a ring, it was more like a streak of light. This is known as a stable auroral red arc, or SAR. Despite the name, it's not an aurora. It's something much rarer. This phenomenon happens when the Earth's magnetic field, which acts like a big protective shield, gets disturbed. This disturbance causes some gas in the atmosphere to get super hot, thanks to a huge electrical current around the planet. What's weird is that only oxygen gets heated up during a SAR, which is why these light shows always glow that same red color. And fun fact, this event is more likely to happen after a big solar storm weakens Earth's magnetic field. It is impressive to see phenomena like this with the naked eye, but the view from outside Earth can be just as stunning. In 2022, an astronaut aboard the International Space Station spotted two bizarre blue blobs of light glimmering in our planet's atmosphere. They happened at the same time, but they weren't related at all. One of them was a massive lightning strike that hit right next to a large circular gap in the clouds. The lightning lit up the surrounding cloud walls, creating a glowing ring around the hole. Another one was caused by the moon. The way the moon was positioned made the sunlight it reflected pass through Earth's atmosphere, creating a bright blue blob with a fuzzy ring around it. And if you're wondering what that weird orange halo is, running parallel to the curvature of the Earth, I've got you. That's the edge of the atmosphere, also known as Earth's limb. And this is what it looks like when viewed from the International Space Station. In Canada, residents of central Alberta were looking up at the sky one night when they suddenly saw something strange. A bunch of vertical beams of light that seemed to be coming from the ground and reaching up into the blackness of space. It sure looked like something out of a science fiction movie, but this is actually just an optical illusion. Yep, it's a visual trick caused by some specific winter conditions. This phenomenon happens when light is refracted by ice crystals. Here's what's going on. When it's freezing outside, tiny ice crystals form in the air. These crystals are super thin and flat, so each one acts like a tiny mirror that reflects light sources positioned below it. Basically, the crystals reflect the light straight up, creating those glowing vertical beams. And it can be caused by any light source, like the sun or the moon. But in most cases, the sources of these light pillars is man-made, like car headlights or streetlights. Even though the phenomenon is completely natural, it rarely happens, and only in very specific situations. First, it has to be freezing cold. On that particular day in central Alberta, for example, the temperature was around -30 degrees Fahrenheit. Then the weather has to be calm, with no wind at all. If a storm breaks out, forget it. You won't be able to see the light pillars. And don't mix them up with auroras, okay? Auroras are mostly seen in high-latitude regions, like around the Arctic and Antarctic. Since they happen way up in the atmosphere, they're visible over large areas. Light pillars, on the other hand, are more localized and concentrated in a much smaller area. But hey, no matter which one you spot, if you're lucky enough to see one of these amazing sights in the sky, you're in for a show you won't forget.
It's official. We now know the exact location and timing of the Yellowstone supervolcano's next eruption, and it's called a supervolcano for a reason. It will be thousands of times more powerful than a typical volcanic eruption. When this happens, the planet will face massive disasters. Earthquakes, tons of magma flows, ashen clouds that will block out the sun. The sky will be gray for a long time. We will have a shortage of food because of the lack of sunlight. Planes won't be able to fly. Some species of animals and trees may disappear. One disaster will follow another, like falling dominoes, one by one. Terrible times await Earth, and okay, stop. It's clear, we got it. But when will all this happen? Don't worry, you won't be left without an answer. When ordinary volcanoes erupt, it's always a disaster, but only for those places that are located near the epicenter. Multiply the damage from an ordinary volcano by thousands and you'll get a supervolcano eruption. Yellowstone is one of the largest volcanic systems in the world. It's erupted 3 times in the last 2.1 million years. The last time was 640,000 years ago. The ash covered an area comparable to about half of the United States. Fortunately, there were no people there, but nature got hurt. A similar eruption of a similar supervolcano occurred about 74,000 years ago. It was the Toba supervolcano in Indonesia that caused an apocalypse the human race barely managed to survive. According to some theories, only a few thousand people stayed alive at the time during the volcanic winter, but it's not confirmed. Since Yellowstone is a volcanic system located in a vast national park, it was important for scientists to find out exactly where the first spark would come from. They found out that Yellowstone's magma doesn't accumulate in one place, but hides in several separate underground reservoirs. The reservoir in the northeast of Yellowstone, next to a beautiful place called Sour Creek Dome, is the riskiest. Here, the red-hot magma comes into contact with the hot rocks of the mantle, which are located deep in the ground. Their high temperature keeps the magma in a liquid state. Imagine that you put a pot of hot milk on the stove. Nothing cools down, but only gets hotter, so the milk may soon begin to rise and flow out of the pan. The same thing is happening with the magma under Sour Creek Dome. Magma doesn't cool down there, and at some point it may start to come out. It'll be like a broken pipe from which a fountain of boiling water gushes. But how did scientists find out? The magma reservoirs are located at a depth of about 6 miles, and this whole area is incredibly hot. They used a special method called magnetotellurics. So, Earth's rotating core creates a magnetic field that surrounds our planet. Magma flows around the core, and it contains many magnetic minerals that also create magnetic fields. Scientists use special instruments that sense those fields emanating from the magma, like a metal detector senses lost jewelry on the beach. Using magnetotellurics, they scanned Yellowstone and discovered 4 large magma reservoirs. 3 of them emitted powerful electromagnetic waves, and in the 4th, which is in the northeast, they recorded a much stronger signal from the magnetic field. This is where the eruption is supposed to occur. But fortunately, it won't happen soon. Perhaps in tens of thousands of years, perhaps in hundreds. Phew, you can relax. No volcanic apocalypse is coming soon. But how do scientists know when this magma will start to erupt? Magma doesn't have a timer, and the volcano doesn't wake up with an alarm clock. So, magma flows inside the pores of solid rock. It resembles a dishwashing sponge with lots of small holes through which water passes. Magma penetrates these pores and fills them.
For magma to start erupting outward, it must fill at least 40% of these pores. About 20% of them are filled now. But these hot rocks continue to heat the magma and keep it liquid, so it can flow between the pores. At some point, it will connect with other pools of the liquid magma and become a large stream that will rise to the top. How can we prevent this from happening? It seems that the solution here is to cool the balsam rocks, but it's impossible to do so. They are several miles deep, they are incandescent, and there are too many of them. And in any case, trying to cool a part of the Earth's core sounds like a very bad idea. All we can do is accept that nature has its own plans. If the eruption occurs in tens or hundreds of thousands of years, then perhaps humanity will find a way to solve this problem. If not, then we should prepare for the consequences. A huge global catastrophe starts with a massive, large-scale explosion. The erupting magma produces a gigantic amount of ash. A powerful burst of energy collapses the Earth's crust over the magma reservoir. This leads to the formation of a giant caldera. You've probably seen a huge crater in a volcano. So, this is the caldera. The natural disaster is so loud it deafens everyone who is nearby. The blast wave rises ash and pumice stone at a speed exceeding the speed of sound. Volcanic materials reach incredibly high altitudes in minutes. Then, this pillar of ash spreads and plunges a huge territory into darkness. The incandescent particles in the lower part fall under their own weight and heat the air around them. It's almost impossible to breathe. The red-hot pieces of pumice stone and ash set fire to the surroundings. All this hot mass turns into pyroclastic flows that destroy and burn everything in their path. Forests, houses, roads, everything turns into coal. No planes can fly there. Tiny particles can penetrate engines. Besides, it's impossible to see through such a dark gray, hot cloud. It's also dangerous to drive cars. Volcanic particles can burn tires. Luckily, thanks to seismic technologies, people have learned in advance about the eruption, so everybody has evacuated. The column of ash that has reached the edge of space continues to expand in different directions. The wind helps the volcanic dust expand. A giant umbrella-like cloud appears over the territory of Yellowstone. It's getting wider and wider and plunges a huge area into hot darkness. During the first 24 hours, ash falls on most of the United States and parts of Canada. It knocks out power lines, pollutes bodies of water, and destroys crops. Then, the rains begin. The water mixes with the ash and falls to the ground in the form of gray mud. And don't forget, it's also poisonous. The ash contains mercury, arsenic, and lead in large quantities. Such toxic masses poison rivers, lakes, land, and air. All this time, the volcano continues to erupt. The outbursts of magma, ash, and pumice can last for several weeks or even a month. And this is just the beginning. The ash soon begins to settle, but the sulfur dioxide released during the eruption spreads all over the atmosphere. This gas mixes with the atmospheric water vapor and forms an aerosol consisting of small particles. All this covers the planet like a veil. This cap makes it difficult for the sun's rays to pass through, which means it lowers the temperature of the Earth's surface. These events cause a sharp cooling of several degrees in the world. Farmers lose a huge amount of their crops. Food prices rise and economies collapse. There might be a famine all over the planet. Human civilization can plunge into chaos. In a few years, the temperature will start rising, but it will take at least a couple of decades to return to previous standards. What will become of humanity by that time? Of course, we will survive, but we'll have to rebuild our civilization. But don't be afraid. If nothing depends on us, let's just enjoy every day of life. Be grateful and help each other. Supporting and caring for each other even during the volcanic winter is a guarantee that humanity will survive.
The floor starts quaking like it's alive. Books, mugs, and lamps leap off shelves. Your feet slide, your body sways, and you can barely stay upright. It stops for a second, but then it shakes again and again. More than 1,000 times just in one day. This is not how you imagined your trip to Santorini, but it's the new reality. The Santorini seismic swarm started in January 2025. In less than 1 month, there were, get ready for it, more than 20,000 reported earthquakes. For comparison, most cities on Earth go through one small, barely noticeable quake in a year. It all started with small jolts that residents could feel, but tourists might have mistaken for large trucks driving nearby. But by February, things got serious. A magnitude 5.3 quake struck. It's a moderate-strength earthquake, but it was strong enough to rattle homes, break windows and dishes, and terrify the island's population. The Greek authorities declared a state of emergency for Santorini and Amorgos. Thousands of people had to leave their homes. Schools closed, and hotels temporarily evacuated their guests. Santorini is famous for its volcano, the one that blew up in a massive eruption around 1600 BCE and inspired the legend of Atlantis. It's still considered to be active, although there have been no significant eruptions since the 1950s. So it would be logical to blame this monster for all the drama. But nope, these tremors weren't volcanic. Experts said what was happening near Santorini looked like a seismic swarm. It's a series of smaller quakes all happening in the same area. They are happening along faults, which are cracks in the Earth's crust that can suddenly shift when the tension gets too high. Think of the ground like a giant, stressed-out Rubik's Cube. At some point, it twists and snaps somewhere. Near volcanic areas like Santorini, fluids moving underground can sneak into these cracks and make them easier to break. Plus, there's the natural stress from tectonic movements. It's like adding oil to a squeaky, overworked hinge. Suddenly, everything slips. Nobody knows exactly what's coming next. Tracking thousands of tremors isn't easy. Many of them are too small for traditional seismic sensors to pick up. But this time, scientists have their new best friend to help out. I'm talking about artificial intelligence. Thanks to machine learning, researchers can detect patterns in tiny vibrations that humans might miss. This technology has helped a lot to understand the swarm. It lets scientists map which parts of the crust are most active and even predict possible future activity. The AI analysis suggests the quakes aren't random. They seem to be clustered along a fault line near the underwater Colombo volcano. This area has a long history of seismic activity. Even though Colombo hasn't erupted recently, the magma beneath it might be subtly shifting the crust, and it adds tension to the tectonic plates above. It's like a simmering pot. Nothing boils over yet, but the heat is definitely building. The swarm has subsided after a couple of months of constant shaking, but it doesn't mean it's over for good. Even after a lull, another swarm could strike, or a larger quake could happen along the same fault lines. That's why scientists are now studying the data collected from the swarm. If you're thousands of miles away from Santorini and don't have plans to visit, it doesn't mean you're 100% safe from a similar scenario. Seismic swarms like the Greek one happened in the Caribbean, Iceland, and Italy. One of the best documented swarms in history happened in Japan, in a suburb northwest of Tokyo. It was all going on in a town sitting on a seismological observatory, like a secret underground lab for tracking earthquakes. The swarm kicked off in August 1965 with just 3 earthquakes that were so weak nobody could feel them. But things escalated fast, and 3 months later, 100 quakes a day were strong enough for people to feel. On one day, the observatory recorded almost 7,000 quakes. Out of those, 585 were strong enough to actually shake the ground, meaning you could feel a quake roughly every 2.5 minutes. Scientists figured out that the swarm was caused by fluids moving underground, kind of like the Earth's crust, stretching and bubbling. Studying seismic swarms helps scientists predict earthquakes better understand how Earth's crust moves, and even prepare for future natural disasters globally. For instance, if they can link the patterns of tremors to magma movement or tectonic shifts, they can apply similar models to volcanoes and fault lines in Hawaii, Iceland, or the Pacific Northwest. Santorini is like a living lab where they combine modern tech with traditional knowledge. AI, seismographs, and satellite imaging add to centuries of human observation. The locals who have lived through quakes for generations contribute insights about small tremors, changes in groundwater, and unusual animal behavior. All this helps scientists refine their models. Santorini's swarm has surely grabbed the attention of the whole world, but it's not the only place on Earth with some intense seismic activity. But what makes Santorini unique is its combination of historical volcanoes, underwater fault lines, and the fact that it's a real tourist magnet. The island is not so large, and the effects of even moderate tremors feel stronger and more dramatic than in other regions. In other places, though, even more serious earthquakes, tsunamis, and volcanic activity are regular news, and the people have learned to live with them. Japan is one of the regions on Earth where earthquakes happen the most because it sits on the edges of 4 tectonic plates. There are around 1,500 of these earthquakes each year that are noticeable. Because of this, the people in Japan have learned to live with earthquakes. There's even a law that sets a rule that buildings in the country should be able to handle earthquakes up to a magnitude of 7 without falling apart. An update 30 years later said that buildings should only have minor damage in such earthquakes and still work as usual. But if an earthquake is even stronger, the law says the building's main job is not to collapse, but to save people's lives. At the most basic level, buildings are made stronger with thicker beams, pillars, and walls so they can handle shaking better. They even construct some buildings on thick layers of padding that separate them from the ground completely, which helps protect them during an earthquake. A skyscraper might sway back and forth a lot and move up to 5 feet, but it won't collapse. On the other side of the Pacific, scientists from the U.S. Geological Survey have studied a dangerous area along the U.S. West Coast. It's called the Cascadia Subduction Zone. Over the past 14,200 years, there have likely been at least 30 big earthquakes in this region. One major quake happened every 500 years on average, but for a long time now, Cascadia has been quiet, and the scientists are getting worried. They think this might be because the area is locked, so the tectonic plates are stuck together and building up a lot of pressure. At some point, a part of the seafloor could suddenly break and move forward by several feet. The shaking would be just 5 minutes, but it would create a powerful tsunami as the seafloor shifts that would last for 10 hours. If it happens, it's going to be the worst natural disaster in the country's history, according to experts. This could make the hillside slide and crumble and take down roads and bridges. Around 620,000 buildings could be badly damaged or even collapse. Scientists are hoping that thanks to advanced AI tech and local communities, they'll be able to better predict earthquakes like this and the one in Santorini. This could save thousands of lives. And for now, we must not forget that the Earth doesn't take vacations when it comes to seismic activity, even in places where you go on vacation.
Divers have found something incredible in a Florida sinkhole, and it was... Stop, we need to leave a warning here. You're about to hear some pretty unusual scientific information. This knowledge will make you the smarty pants in your friend group. But there's also a risk that they'll look at you as a nerd. So perhaps it would be better for you to keep this knowledge a secret. In any case, it won't be superfluous. So, you know that scientists divide the history of our planet not only by time periods, but also by which animals lived at a certain time. For example, 2,000 years ago, Earth was inhabited by the blobfish, and scientists call this time the blobfish period. It's a joke, there's never been such a period, but you get the gist. The period between about 419.2 million and 358.9 million years ago is called the Devonian period, or the Age of Fish. Do you know why? Because the first fish began to appear on the planet. The Paleogene is the period of large mammals. The famous Jurassic period marks the appearance of giant dinosaurs, which we often see in the movies. Even now, we live in a certain period called the Quaternary period. It began about 2.6 million years ago and continues to this day. This is the time of humans and modern animals. So the next time somebody asks you what time it is, you can just answer, it's the Quaternary period. In short, the names of these periods depend more on what creatures inhabit the planet. The longest period is the Precambrian period, or Age of Early Life, the time when life on the planet started to form. Soft-bodied worms and jellyfish swam in the ocean, while microorganisms lived on land. This period occupies almost 90% of the Earth's total geological time. It started about 4.5 billion years ago and ended 540 million years ago. Oh, it's still a video about divers, don't forget. We'll get back to them soon. Considering all these periods, do you know which one is of the most poorly studied? A period about which scientists know almost nothing, especially about the animals that lived at that time. This is the Irvingtonian North American land mammal age. It lasted from about 1.6 million to 250,000 years ago. Scientists have very few fossils that belong to this time, but recently, everything has changed. In the USA, there's the Steinhatchee River, which stretches for several tens of miles in the area of Big Bend, Florida. And just 500,000 years ago, there was a sinkhole instead of the river. This is a hole in the ground that forms when water dissolves the upper rock. This rock is often limestone. Sinkholes appear in places with a lot of precipitation. Sometimes these pits can be invisible. They look like ordinary ground, but the soil in them is loose and can easily collapse. If you accidentally get into a sinkhole, people will hear your screams and help you. But in the distant past, about 500,000 years ago, when animals got there, they couldn't get out of the pit, so it became their grave. After many years, a river appeared here, and then several fossil collectors decided to check out this place and discovered a real paleontological treasure in it. They plunged into the river and reached the bottom. There, in the murky water, they saw horse teeth sticking out of the sediment. It'd be pretty scary to find for many of us, but for these guys, it was the jackpot. After the teeth, they found a hoof shaft and the skull of an unusual animal. At that moment, the collectors realized they had made a major discovery. Over the years, the sinkhole at this place had been filled with sedimentary rocks. Then, the river compacted all this mass, which made it possible to keep everything inside the sinkhole in good condition. Many animals got trapped in this pit 500,000 years ago, and only now have people managed to get them out. More precisely, what's left of them. Divers have found more than 500 fossils belonging to ancient animals, including unknown species. They got well-preserved bones of ancient horses, giant armadillos, sloths, and a new species of tapir. The Florida Museum examined the remains and determined that they belonged to the poorly studied Irvingtonian North American land mammal age. Most of all, scientists were struck by two finds in this collection. The first was the remains of a giant armadillo-like creature, and the second was the skull of an ancient tapir. In case you didn't know, this is a very cute pig-like mammal that has a short trunk like an elephant. Divers in Florida found the remains of a distant ancestor of this animal, which may be a new unknown species. Most of the fossils in this sinkhole belong to early Caballine horses, a subgroup that includes modern domestic horses. The remains of horses are so well preserved that scientists have seen signs of wear on their teeth. This will allow experts to understand the diet of these ancient creatures. We often hear news about people finding the remains of ancient animals or dinosaurs in caves, ravines, or at the bottom of lakes. But imagine if they found such remains in a museum. It all started in the early 2000s, north of the Florida border in southwest Georgia. There was a mine where workers mined clay. One day, they found the remains of some ancient animals and gave them to the Florida Museum of Natural History. There, these remains lay in storage, waiting in the wings. And then one day, some guy started sorting them out and noticed a mysterious vertebra of an unknown animal. This little grab caught the guy's attention, so he returned to it over and over again. He studied it, trying to figure out what species the bone belonged to. One day, he realized the bone belonged to an unknown extinct lizard species that looked like a tegu. You've probably seen these predatory creatures that look like monitor lizards. So, the age of the bone was about 15 to 17 million years old. Let's wrap up our video with something weird. You see this piece of amber-colored stone with stripes? Or is it not the stone? It looks like an ancient seashell. So right now, you're looking at the oldest fossil in history. It's a stromatolite, and its age is, you won't believe it. Make a guess. 100 million years? 500 million years? 1 billion? No. This fossil is about 3.4 billion years old. It represents one of the earliest forms of life on Earth. No, not the stone itself. Stromatolite is just a playground. The early form of life here is these thin strips. They're called cyanobacteria, tiny single-celled creatures. Okay, what about the remains of something bigger? Some ancient animals, for example? Meet the trilobites. They lived here during the Cambrian period, which began about 500 million years ago. This is the time when many invertebrates and fish began to appear. Their exoskeletons helped the trilobites stay remarkably well preserved, considering their age. They were arthropods that looked like something between a spider, a scorpion, and a mutant from another galaxy. These animals lived for a very long time, and people find their remains almost all over the world. They appeared at the very beginning of the Cambrian period, survived it, and became extinct at the end of the Permian period. During the Permian mass extinction, when about 90% of all living beings were wiped off the face of the Earth. These creatures swam in open water, burrowed into the seafloor, or crawled along it. They lived like predators and scavengers. The front of the animal was protected by a strong head shield. It had crescent-shaped eyes and a calcified plate on its lower body. This plate covered its esophagus and mouth. It had several pairs of legs growing from its body. The trilobite could also curl